For 3 centuries, the methods of science had been remarkably successful in explaining features of the natural world that earlier traditions had explained through religious and philosophical frameworks. Galileo turned his telescope toward the heavens, and the movements that earlier centuries had attributed to angelic intelligences turned out to follow the same laws that governed falling stones on Earth. Newton wrote down the equations of motion, and the universe became, for many thinkers, a vast clockwork mechanism whose operations could be calculated without reference to anything beyond its material parts. Darwin published The Origin of Species, and the diversity of living forms turned out to be explicable through processes of variation and selection rather than through specific acts of divine creation. By the late 19th century, the materialist framework had become so successful that many serious thinkers treated it as the only intellectually defensible position available. The universe was matter in motion. Consciousness was a byproduct of brain activity. The questions that earlier traditions had addressed about the relationship between consciousness and reality, about what happens at death, about whether existence has dimensions that exceed what material processes can provide, were widely treated as questions that scientific progress had superseded. And then, beginning in 1900, the framework began to break. The man who broke it was Max Planck, working in a Berlin laboratory on a specific technical problem about how heated objects emit radiation across different wavelengths. The classical predictions disagreed with what was actually measured. Planck found that the mathematics worked only if energy came in discrete units rather than continuous flows. He called the discovery an act of desperation. He had been a careful materialist scientist. He had no interest in disrupting the framework that his entire training had been built within. He spent the following 2 decades trying to reconcile the discovery with the classical framework. The reconciliation never came. The implications of what Planck had found were worked out across the following years by Einstein and Bohr, by Heisenberg and Schrödinger, by Pauli and Dirac and Born, by physicists across Europe, and eventually across the world. By the late 1920s, the structure of classical physics had been transformed in ways that no one in 1900 could have anticipated. The atoms that had been understood as solid building blocks of matter behaved in ways that no classical framework could accommodate. Particles exhibited wave-like properties. The act of measurement participated in determining what was measured. 2 particles separated by vast distances remained correlated through what Einstein would later call spooky action at a distance. By 1944, in a public speech in Florence, Planck himself articulated what the new physics had brought him to. All matter, he said, originates and exists only by virtue of a force which brings the particles of an atom to vibration. We must assume, behind this force, the existence of a conscious and intelligent mind. This mind is the matrix of all matter. The framework that Planck was articulating, that the cosmos has at its foundation an intelligent ordering principle from which material reality unfolds, was not something he had derived from any prior religious commitment. He had been led to it, reluctantly, by the implications of the physics he himself had begun, and yet the framework was not new. The doctrine of Logos developed in Christian theology beginning with the Gospel of John in the 1st century. In the beginning was the Logos, and the Logos was with God, and the Logos was God, articulates the position that the cosmos has at its foundation, a kind of intelligent ordering principle from which all reality proceeds. The Logos doctrine was elaborated across centuries of Christian theology through the work of Justin Martyr in the 2nd century, the Cappadocian Fathers in the 4th, Augustine in the 5th, and into the modern period. The doctrine of Brahman articulated in the Hindu Upanishads more than 2,000 years before Planck delivered his Florence speech, the framework of Tao that Taoist philosophers had been articulating in China since the 6th century before the Common Era, the Stoic doctrine of the Logos Spermatikos, developed by Greek philosophers contemporary with the writing of the Christian Gospels. Each of these traditions had developed, in its own different vocabulary, a position that bears striking structural resemblance to what Planck was now articulating from within the most rigorous physics of the 20th century. Whether Planck was independently arriving at something these traditions had been articulating for thousands of years, or whether he was using available philosophical vocabulary to express what the physics had brought him to, or whether the convergence is structural coincidence between very different inquiries is a question that no current research can definitively settle. The convergence is real. The interpretation is yours. Albert Einstein, whose theories of relativity transformed our understanding of space and time as profoundly as Planck's work had transformed our understanding of matter, articulated his own position with characteristic care. Einstein was not a religious man in the traditional sense. He did not believe in a personal God who answered prayers or intervened in human affairs. When asked about his religious views, he described himself as believing in the God of Spinoza, the 17th century Dutch philosopher who had identified God with the totality of nature itself, what Spinoza called Deus, sive, natura, God or nature. The position that Einstein was articulating through this reference was neither the traditional theism of the Abrahamic religions, nor the materialist atheism that the previous century had developed. It was a third position, in which the deepest structures of physical reality were expressions of something more than merely material processes, while also not being the personal deity of traditional religious worship. Science without religion is lame, Einstein wrote in 1954. Religion without science is blind. The framework that Einstein was drawing on through Spinoza has parallels in the Hindu tradition of Brahman, the deeper underlying reality from which the apparent world of separate objects emerges, articulated most fully in the Advaita Vedanta tradition, developed by the 8th century philosopher Shankara. The Christian tradition has developed similar frameworks through what its mystical theologians have called panentheism, the position that the divine includes and exceeds the natural world rather than being identical to it. The Taoist tradition has articulated through the concept of Tao, a framework in which the deeper ordering of reality is neither personal in the theistic sense, nor merely material in the modern scientific sense. Whether Einstein was independently arriving at a framework these traditions had developed across millennia, or whether he was using available philosophical vocabulary to articulate a position that the physics permitted but did not strictly require, is one of the questions that continues to be debated. Werner Heisenberg, whose uncertainty principle established one of the most fundamental limitations on what physics can know about the physical world, articulated his philosophical position with particular directness in his 1958 book, Physics and Philosophy. The framework that quantum mechanics revealed, Heisenberg argued, was not the classical materialism that the 19th century had taken for granted. It was closer to what Plato had articulated more than 2,000 years earlier in the Timaeus. The fundamental constituents of reality, on Heisenberg's reading, were not the material objects that classical physics had assumed. They were mathematical patterns or forms that gave rise to the appearances we encounter as physical objects. The atoms of contemporary physics, Heisenberg wrote, are closer to the Platonic forms than to the small material billiard balls that the 18th century had imagined. Plato's framework in the Timaeus, composed around 360 before the Common Era, treats the physical world as the manifestation of mathematical and geometrical structures that exist in a deeper level of reality, with the apparent material objects being expressions of these deeper patterns rather than independently existing material things. The framework that Heisenberg was articulating through the reference to Plato has parallels far beyond the Greek philosophical tradition. The Hindu doctrine of Namarupa, name form, developed in the Upanishads more than 2,000 years before quantum mechanics, articulates a framework in which the apparent physical objects are manifestations of deeper structural patterns rather than independently existing material things. The Buddhist Yogacara school, developed in India in the 4th century through the work of Vasubandhu in his Vimsatika, articulated a similar framework in which the objects of perception are mind-only, Naptimatra, with the apparent material world being constituted by deeper informational patterns. The Christian tradition has articulated this framework through the doctrine of the divine ideas, the position developed most fully by Augustine in his commentary on Genesis and by Aquinas in the Summa Theologiae, that physical objects exist as expressions of ideas in the divine mind, rather than as independently existing material things. The Islamic philosophical tradition has articulated similar frameworks through the work of philosophers, including Al-Farabi and Ibn Sina, in the 10th and 11th centuries, who developed Aristotelian and Platonic frameworks within the context of Islamic theology. Whether Heisenberg's framework reflects a genuine recognition that these traditions had been articulating, or whether it reflects Heisenberg projecting Platonic categories onto a physics that does not strictly require them, is a question that has continued to be debated among historians and philosophers of science across the past 70 years. Erwin Schrödinger, whose equation describes the behavior of every quantum system from the atom to the cat in his famous thought experiment, devoted substantial portions of his philosophical writing to arguing that the framework most adequate to what quantum mechanics revealed was something specifically older than even Plato. In his 1944 book, What is Life? And in his subsequent essays collected as My View of the World, Schrödinger argued that the materialist framework was inadequate to account for the unity of conscious experience. He went further. He argued that the framework most adequate to what his physics had revealed was the Vedantic doctrine of consciousness articulated in the Upanishads of ancient India. There is, Schrödinger wrote, only one mind. The apparent multiplicity of conscious experiences is the appearance produced by the one mind expressing itself through specific embodied forms. The framework that Schrödinger was drawing on had been articulated in the Brihadaranyaka Upanishad and the Chandogya Upanishad more than 2,500 years before quantum mechanics existed, and had been developed across centuries of philosophical refinement through the work of Shankara in the 8th century and the broader tradition of Advaita Vedanta. The Advaita framework holds that what appears as the multiplicity of separate conscious beings is the appearance produced by the deeper underlying unity that the tradition calls Brahman, with the apparent multiplicity being what the tradition calls Maya. The framework was not unique to India. The Christian tradition has articulated structurally parallel positions through its mystical theology, most fully in the work of Meister Eckhart in the 14th century, who argued that the deeper ground of the soul is identical with the deeper ground of divine reality, and in the work of Nicholas of Cusa in the 15th century, who developed similar frameworks through his doctrine of the coincidence of opposites. The Buddhist Mahayana tradition has articulated similar frameworks through the doctrine of Buddha nature, the position that all conscious beings participate in a deeper Buddha mind that is their fundamental identity. The Taoist tradition has articulated similar frameworks through the concept of Taowa as the deeper unity from which the apparent multiplicity of phenomena emerges. Schrödinger's engagement with the Vedantic framework was not casual. He studied the Upanishads carefully across many years. He read the Sanskrit philosophical tradition both through direct translations and through the commentaries of Indian philosophers who had developed the framework across centuries. His own articulations of the unity of consciousness in his philosophical writings draw extensively on the specific vocabulary of Advaita Vedanta. Whether Schrödinger was correct that this ancient tradition had developed a framework that contemporary physics is now in the process of rediscovering, or whether he was simply expressing his personal philosophical preferences in a vocabulary that the physics did not require, is one of the questions that careful inquirers have continued to engage. The convergence between Schrödinger's interpretation of his equation and the framework that Indian philosophers had developed across millennia, with parallels in Christian, Buddhist, and Taoist traditions, is at minimum striking. It is also not proof. Wolfgang Pauli, whose exclusion principle is foundational to our understanding of atomic structure and whose work won him the Nobel Prize in 1945, developed an extended intellectual collaboration with the Swiss psychologist Carl Jung that produced one of the more unusual documents in the history of 20th century thought. The Pauli-Jung correspondence, conducted across decades and culminating in their joint volume Naturerklärung und Psyche in 1952, addressed the relationship between physics and psychology through frameworks that drew on both contemporary science and older philosophical and contemplative traditions. The book introduced Jung's concept of synchronicity, the meaningful coincidence of events that have no causal connection in the standard physical sense, and connected it to specific features of quantum mechanics that Pauli articulated. The framework that emerged treated the apparent separation between mind and matter as an artifact of how we ordinarily think about the world, rather than as a feature of reality itself. The deeper level, on the Pauli-Jung framework, involves what they called unus mundus, one world, in which mind and matter are different aspects of a single underlying reality. The Latin term unus mundus had been used by Renaissance philosophers and earlier Christian mystics to articulate a structurally similar position, particularly through the work of the 16th century physician and alchemist Gerhard Dorn, whose writings on the unity of mind and matter Jung studied extensively. The framework that Pauli and Jung were drawing on through this reference reaches back to the Neoplatonic tradition that had developed in the centuries after Plato through the work of Plotinus in the 3rd century and Proclus in the 5th century. The Hindu tradition has articulated similar frameworks through the doctrine of Advaita, non-duality, developed by Shankara, in which the apparent multiplicity of phenomena is the expression of a deeper unity that the tradition calls Brahman. The Buddhist Mahayana tradition has articulated similar frameworks through the doctrine of pratityasamutpada, dependent origination, in which all apparent phenomena arise through their interrelationships rather than as independently existing realities, and through the related framework of the Huayan school developed in China in the 7th century, with its image of Indra's net, in which every node reflects every other node. The Sufi tradition within Islam has articulated similar frameworks through the doctrine of Wahdat al-Wujud, the unity of being, developed most fully by Ibn Arabi in the 13th century. The framework was not new to Pauli and Jung. They were articulating, in the vocabulary of mid-20th century physics and psychology, a position that contemplative and philosophical traditions across multiple cultures had developed across more than 2 millennia. Whether their articulation reflects a genuine recognition of something the traditions had been pointing to, or whether it reflects their importing older philosophical categories into contemporary fields that did not strictly require them, is one of the questions that careful inquirers continue to engage. Niels Bohr, whose interpretation of quantum mechanics shaped the broader field for most of the 20th century, made his own engagement with ancient philosophical traditions explicit when he was knighted by the Danish government in 1947 and chose his coat of arms. He chose the yin-yang symbol, the ancient Chinese representation of complementary opposites that had been central to Taoist philosophy since the 6th century before the Common Era, and added below it the Latin phrase contraria sunt complementa, opposites are complementary. Bohr had been thinking about the principle of complementarity in physics, the recognition that quantum systems exhibit different complementary aspects depending on how they are measured. Light behaves as a wave in some experiments and as a particle in others. Position and momentum cannot be simultaneously measured with perfect precision. The complementarity that Bohr was articulating in physics seemed to him to parallel what Taoist philosophers had been articulating for more than 2,000 years about the complementary nature of all phenomena in the broader Tao that organizes reality. The Taoist framework that the yin-yang symbol represents, articulated most fully in the Tao Te Ching, attributed to Laozi in the 6th century before the Common Era, and elaborated extensively in the writings of Zhuangzi a century later, treats the apparent oppositions of phenomena as expressions of a deeper structural unity. Light and darkness, motion and stillness, fullness and emptiness, being and non-being. Each of these apparent oppositions is the expression of a single underlying pattern, rather than the manifestation of fundamental conflict. The framework had been developed across more than 2,000 years of Chinese philosophical reflection before Bohr articulated what he took to be a structurally similar framework in his interpretation of quantum mechanics. The framework has parallels in the Christian tradition through what theologians have called the coincidentia oppositorum, the coincidence of opposites, developed most fully by the 15th century theologian Nicholas of Cusa, who argued that the divine reality contains within itself the resolution of apparent contradictions that the finite human mind cannot reconcile. Cusa's framework anticipates in remarkable ways what Bohr would later articulate as the principle of complementarity in physics. The Hindu tradition has articulated similar frameworks through the doctrine that the apparent oppositions of the world are reconciled at the level of Brahman, with the framework being developed most fully through the Vedantic traditions and through specific schools, including the Trika Shaivism that developed in Kashmir in the 9th and 10th centuries, the Buddhist Madhyamaka tradition, developed by Nagarjuna in the 2nd century, articulated frameworks within which apparent oppositions are revealed as constructions of conventional understanding that dissolve when examined through the lens of dependent origination. Whether the parallel between Bohr's complementarity and these various traditions reflects a genuine philosophical recognition that contemporary physics is now rediscovering, or whether it reflects Bohr decorating his physics with Eastern imagery that did not actually correspond to what the physics revealed, is a question that has continued to be debated. What can be said with certainty is that Bohr himself, when asked to represent the deepest framework of his thought through a single symbol on his coat of arms, chose an image that had been developed by Taoist philosophers more than 2,500 years before quantum mechanics existed, and that bears structural resemblance to frameworks developed independently across Christian, Hindu, and Buddhist traditions. What emerges from the reflections of these early quantum physicists, considered together, is a striking pattern. Several of the most important scientists of the 20th century, working at the foundations of the materialist science that the previous century had constructed, arrived at positions that the materialist framework alone could not adequately accommodate. They did not arrive at these positions through religious conversion in any conventional sense. They arrived at them through the implications of their own rigorous scientific work, with the implications carrying them to frameworks that the contemplative and philosophical traditions of the world had developed across thousands of years. Planck found his way to a position that Christian theology had been articulating since the Gospel of John. Einstein found his way to a position that the Spinozist tradition had drawn from Jewish, Christian, and broader philosophical sources. Heisenberg found his way to Plato, whose framework had parallels in Hindu, Buddhist, and Christian thought. Schrödinger found his way to Vedanta. Pauli and Jung found their way to a framework with roots in Neoplatonism, Christian mysticism, Hindu Advaita, and Buddhist Mahayana. Bohr found his way to Taoism. Each of these physicists, working within the most rigorous science of his time, was led by the implications of that science to engage seriously with frameworks that the scientific revolution of the previous 3 centuries had treated as superseded. They did not return to traditional religion in any naive sense. They recognized, from within the most rigorous science of their time, that the questions they were now addressing were questions that the great traditions had spent thousands of years working on, and that the answers those traditions had developed deserved serious engagement rather than dismissal. Whether the convergence between contemporary physics and the ancient traditions reflects something genuine about the structure of reality, or whether it reflects the specific philosophical preferences of the physicists who articulated it, or whether the convergence is the consequence of physicists importing older categories into a physics that does not strictly require them, is the question that this documentary will examine across its subsequent stages. The orientation of this examination matters and should be stated at the outset. This documentary does not argue that contemporary physics has confirmed any specific religious tradition. It does not argue that ancient traditions anticipated contemporary physics in any precise sense. It does not endorse the popular claim that quantum mechanics proves the existence of God, the immortality of the soul, the power of mind to create reality, or any of the various other claims that have been made by various popularizers across the past several decades. The careful position which this documentary will attempt to maintain across its subsequent stages is that the convergences are real and worth examination, but that the convergences fall short of proof, and that any account claiming they amount to proof is overstating what the available evidence supports. What contemporary physics has done is to reopen questions that the materialist framework had treated as closed. The reopening is genuine. What the reopening permits is genuine. What it establishes is more limited than the popular accounts of these matters often suggest. The work of the documentary is to maintain this careful position while examining specific questions in detail and leaving the broader interpretation to the careful judgment of those who follow the examination through to its conclusion. Consider, as a preliminary illustration of the kind of analysis that will follow across the subsequent stages, the question of the observer in quantum mechanics. The standard interpretation of quantum mechanics, developed by Niels Bohr and Werner Heisenberg in the late 1920s, holds that the act of measurement participates in determining the outcome of quantum experiments. Particles do not have definite positions and definite momenta independent of measurement. The measurement participates in determining what the particle is, with the determination being a feature of the measurement process, rather than the revelation of properties that the particle had all along. The double-slit experiment, replicated thousands of times across the past century, demonstrates this in laboratory conditions. Particles behave as waves when unobserved, and as particles when measured. The phenomenon is documented physics, established through decades of experimental work and forming the foundation of contemporary quantum theory. What the documented physics actually means, however, has been one of the most contested questions in the field. Bohr's interpretation treats the measurement dependence of quantum properties as a feature of reality itself. The many worlds interpretation, developed by Hugh Everett in 1957, treats the apparent collapse as the branching of universes, within which all possible measurement outcomes are actualized. The Penrose-Hameroff orchestrated objective reduction theory, developed across the past several decades by Roger Penrose at Oxford and Stuart Hameroff at the University of Arizona, treats the collapse as triggered by gravitational effects at the fundamental level of physical reality. None of these interpretations has been definitively established. The physics is documented. The interpretation is theoretical. The question of whether reality requires an observer in some fundamental sense, whether consciousness participates in shaping what we encounter as physical reality, remains one of the most contested questions in contemporary philosophy of physics. And yet the question is not new. The Upanishads of ancient India, composed across centuries beginning around the 8th century before the Common Era, articulated frameworks within which consciousness and reality are not the separate categories that ordinary thinking assumes them to be. The Brihadaranyaka Upanishad articulates a vision in which the deeper reality of consciousness, what the tradition calls Brahman, is the ground from which the apparent world of separate objects emerges, rather than a feature added to an independently existing material world. The Chandogya Upanishad develops this framework through its central teaching of Tat Tvam Asi, that thou art, the recognition that the consciousness of the individual being is not separate from the broader reality of Brahman, but is its specific local expression. The framework was developed across centuries of Hindu philosophical refinement, with its most rigorous articulation coming through the Advaita Vedanta tradition developed by Shankara in the 8th century. The Yogacara school of Buddhism, developing in India in the 4th century through the work of Vasubandhu in his Vimsatika and Trimsika, articulated frameworks within which the apparent objects of perception are not independent realities, but are manifestations of consciousness itself. The framework was elaborated across centuries by Buddhist philosophers, including Dignaga and Dharmakirti, and was transmitted through East Asia, where it became foundational to Chan and Zen Buddhist thought. The Christian tradition has developed, across 2,000 years of theological reflection from Augustine through Aquinas and into modern thought, the doctrine of creatio continua, continuing creation, in which the world exists moment by moment through the sustaining awareness of God, rather than through any independent existence. The framework was articulated by Augustine in his Confessions and elaborated extensively through scholastic theology, with its specific philosophical articulation being that the world has no aseity, no being in itself, but exists only through the continuing creative act of divine awareness. The Taoist tradition has articulated through the broader framework of Tao the position that what appears as separate phenomena is the expression of a deeper unity in which the distinction between observer and observed is not as fundamental as ordinary thinking assumes. The Zhuangzi articulates this most directly through the famous parable of the butterfly dream, in which the boundary between the dreamer and the dreamed becomes one of the central philosophical puzzles of the tradition. Each of these traditions developed its framework without any access to the experimental tools of contemporary physics. Each was working through the methods of sustained contemplative practice and careful philosophical reflection across many centuries. Whether the convergence between what these ancient traditions articulated and what contemporary physics has begun to suggest in its various interpretations of the observer problem is meaningful, or whether it is structural coincidence between very different inquiries operating in very different contexts, or whether contemporary physics is being interpreted in ways that import ancient philosophical categories the physics itself does not require, is a question that no current inquiry can definitively settle. What can be said with confidence is this: the ancient traditions articulated frameworks that bear striking structural resemblance to what contemporary physics in its various interpretations has revealed. The frameworks were developed without any access to the experimental tools of contemporary physics. The frameworks were developed by inquirers who were addressing what they took to be deep questions about the structure of reality, using the methods of contemplative practice and philosophical reflection rather than the methods of laboratory measurement. The structural resemblance between what these ancient inquirers articulated and what contemporary physics has begun to suggest is one of the more striking patterns in the history of human thought. The resemblance does not establish that the ancients knew what contemporary physics is now discovering. The resemblance establishes that the questions are old, that careful inquirers across many centuries have addressed them with serious philosophical and contemplative resources, and that contemporary physics is one specific contribution to a much older inquiry rather than a complete replacement of what came before. The structure of this documentary across its subsequent stages will be to examine specific questions in this manner with attention to what contemporary physics has actually established, what its various interpretations suggest, and what the great traditions of the world have articulated about the same questions across thousands of years. The next stage will examine the question of the observer and consciousness with more depth than this preliminary discussion has permitted, drawing on the work of physicists from Wheeler to Wigner to Penrose, and on the contemplative traditions from Vedanta to Yogacara to Christian mystical thought. The subsequent stages will examine the questions of time and eternity, of connection and non-locality, of death and information, of consciousness and mind, and of the broader structure of reality as information. Each stage will move in the manner that this stage has attempted, examining the documented physics, the interpretations the physics has supported, and the structurally parallel frameworks that the great traditions have developed, with the convergences being identified and the questions about their interpretation being left for you to develop your own answers to. The patterns we will encounter across these stages have already been previewed in this preliminary examination. Contemporary physics, in its various interpretations, has revealed structural features of reality that the merely materialist framework cannot adequately accommodate. The great traditions of the world have articulated frameworks across thousands of years that bear striking structural resemblance to what contemporary physics is now uncovering. The convergence is striking. The convergence is not proof. What follows from the convergence depends on what one brings to its interpretation. What you make of any of this, by the time the examination has run its course, is a question whose answer is yours alone to develop. What this documentary can offer is the resources for the development. The convergences are striking. The convergences are not proof. The interpretation of the convergences is yours. In the autumn of 1927, 29 of the most important physicists of the 20th century gathered in Brussels for what would become the most famous scientific conference in history. The 5th Solvay Conference on Physics, hosted at the Hotel Metropole and funded by the Belgian chemical industrialist Ernest Solvay, brought together Albert Einstein, Niels Bohr, Werner Heisenberg, Erwin Schrödinger, Max Planck, Marie Curie, Wolfgang Pauli, Paul Dirac, and others, to debate the meaning of the new quantum mechanics that had been developing across the previous 2 decades. The conference produced the famous photograph in which 17 of the 29 attendees were current or future Nobel Prize winners. It also produced one of the most consequential intellectual disputes in modern thought. The dispute centered on what the new physics actually meant for the nature of physical reality, and at the heart of the dispute was a question that the great philosophical and contemplative traditions of the world had been addressing for more than 2,000 years. The question was whether the act of observation participates in shaping what is observed, or whether the observed reality exists in some definite form, independent of any conscious engagement with it. Einstein took one side. Reality, he insisted, must have definite properties whether anyone observes it or not. The moon must exist whether anyone looks at it. He wrote, in his famous correspondence with Max Born, that he could not bring himself to accept that God plays dice with the universe. Bohr took the other side. The properties of quantum systems, he insisted, are not features that exist independently of the conditions of their observation. The act of measurement is part of what determines what the quantum system is. The debate between Einstein and Bohr continued for the remaining 3 decades of their lives, with each man defending his position with increasing sophistication and neither convincing the other. Einstein died in 1955, still convinced that the framework must be incomplete. Bohr died in 1962, still convinced that the framework was as complete as nature permitted physics to be. The question they were debating was not a new question. 23 centuries earlier, the Greek philosopher Plato had argued in the Republic and the Timaeus that the physical world we encounter through our senses is not the deepest level of reality, but is the appearance of deeper structural patterns that exist independently of any particular observation. The framework was elaborated across centuries of Greek philosophical reflection. The Christian tradition has developed across 2,000 years of theological reflection. The doctrine of creatio continua, continuing creation, in which the world exists moment by moment through the sustaining awareness of God. Augustine articulated this framework in the Confessions, and Aquinas elaborated it in the Summa Theologiae, with the framework holding that no created thing has being in itself, but exists only through the continuing creative act of divine awareness. Without this continuing awareness, on the framework that scholastic theology developed, all created things would immediately return to nothingness. The Hindu Upanishads, composed across centuries beginning around the 8th century before the Common Era, articulated frameworks within which consciousness and reality are not the separate categories that ordinary thinking assumes. The Brihadaranyaka Upanishad treats the deeper consciousness, what the tradition calls Brahman, as the ground from which the apparent world of separate objects emerges, rather than as a feature added to an independently existing material world. The Buddhist Yogacara school, developing in India in the 4th century through the work of Vasubandhu in his Vimsatika, articulated frameworks in which the apparent objects of perception are manifestations of consciousness itself. The frameworks differ in their specific theological commitments. They share the recognition that the simple picture of an observer externally watching a reality that exists independently of the observation is not as fundamental as ordinary thinking assumes. The question that Einstein and Bohr were debating in Brussels in 1927 was a question that these traditions had been addressing through different vocabularies for more than 2,000 years. The experimental work that has developed across the century since the Solvay conference has only deepened the strangeness of what is happening at the quantum level. The double-slit experiment, which began with the English physicist Thomas Young in 1801 demonstrating that light behaves as a wave, has been refined across the decades to test increasingly subtle features of the relationship between observation and reality. Young's original demonstration, conducted in his laboratory at the Royal Institution in London, was decisive in the debate over whether light was particles or waves that had been continuing since Newton, who had argued for particles, and Huygens, who had argued for waves. Young's experiment seemed to settle the question in favour of waves. The settlement lasted for roughly a century. In 1905, Einstein's analysis of the photoelectric effect demonstrated that light also behaves as particles under specific conditions, and the dual nature of light became one of the central puzzles that the new physics would have to address. By the 1920s, it had become clear that all quantum entities, light and matter alike, exhibit both wave-like and particle-like properties, depending on how they are measured. The American physicists Clinton Davison and Lester Germer demonstrated in 1927, the same year as the Solvay Conference, that electrons could produce interference patterns when passed through a crystal lattice, establishing experimentally that matter behaves as a wave under appropriate conditions. The Japanese physicist Akira Tonomura performed in 1989 the most striking version of the experiment, sending single electrons through a double-slit apparatus one at a time and watching an interference pattern build up over time. Each individual electron, when not observed during its passage, behaved as a wave going through both slits simultaneously. When the electrons were observed during their passage, they behaved as localized particles going through one slit or the other. The observation itself changed the nature of what was observed. The particles seemed to know whether they were being watched. The phenomenon has survived every attempt to explain it within classical frameworks. What it actually means remains one of the most contested questions in contemporary physics. The American physicist John Wheeler, working at Princeton in the 1970s, pushed the question even further with his delayed choice experiments, proposed in 1979 and subsequently realized in laboratories around the world. The decision about whether to observe a particle's passage, in Wheeler's framework, could be made after the particle had already passed through the barrier, with the experimental outcome still depending on whether the observation was eventually made. Wheeler proposed in 1983 a cosmic version of the experiment, in which the light from a distant quasar passing through a gravitational lens billions of years ago would still depend on whether an astronomer on Earth eventually observed which path it took. The implications were difficult to accept within any classical framework. Wheeler developed from these experiments what he called the participatory universe, summarized in his later writings through the phrase "it" from bit, the position that reality at its foundation is informational rather than material, with material phenomena being expressions of deeper informational structures. What Wheeler was articulating bears striking structural resemblance to what the great traditions had been articulating across millennia. The Hindu doctrine of Tat-Tvamasi, that thou art, developed in the Chandogya Upanishad more than 2,500 years before Wheeler proposed his delayed choice experiment, articulates the position that the deeper consciousness of the individual being is identical with the deeper reality of the cosmos, rather than being a separate observer of it. The framework was developed across centuries of Hindu philosophical refinement and was formalized most rigorously through the Advaita Vedanta tradition developed by the 8th century philosopher Shankara, who argued that what appears as the multiplicity of separate observers and observed objects is the appearance produced by the deeper underlying unity of Brahman. The Buddhist Yogacara framework articulates a structurally similar position. The Christian framework of creatio continua articulates a related position in different vocabulary, with the divine awareness participating in sustaining the existence of all created things moment by moment. The Christian mystic, Meister Eckhart, writing in the 14th century in his sermons in Cologne and Strasbourg, developed this framework with particular philosophical depth, arguing that the deeper ground of human consciousness is not separate from the deeper ground of divine reality, but is its specific local expression. Eckhart's articulation, which placed him under suspicion of heresy and led to his trial in Avignon in 1326, was that the divine is not a being external to the human soul, but is the deeper reality that the soul participates in at its ground. The Taoist framework articulates the participation of observer and observed in Tao through the philosophical reflections of Zhuangzi, whose famous parable of the butterfly dream raises the question of whether the philosopher dreaming of being a butterfly and the butterfly dreaming of being a philosopher are genuinely distinct. The frameworks share, despite their substantial theological differences. The recognition that the simple picture of an observer externally watching a reality that exists independently is not adequate to what the deeper investigation reveals. Whether Wheeler was articulating something these traditions had been pointing to for millennia, or whether the convergence is structural coincidence between very different inquiries, is a question that no current research can definitively settle. The strangeness of the quantum framework was articulated most famously by Erwin Schrödinger in 1935 through what has become known as Schrödinger's cat. The thought experiment, which Schrödinger originally proposed in a paper that was itself critical of what he took to be the absurd implications of the Copenhagen interpretation, has become one of the most widely discussed scenarios in the entire history of physics. Imagine, Schrödinger suggested, a cat sealed in a box along with a radioactive atom and a vial of poison. The atom has a 50% probability of decaying within an hour. If it decays, it triggers a mechanism that breaks the vial and kills the cat. If it does not decay, the cat remains alive. According to the standard interpretation of quantum mechanics, the atom is in a superposition of decayed and undecayed states until it is observed. The implications, as Schrödinger pointed out, seem to require that the cat be in a superposition of dead and alive states until the box is opened and the cat is observed. Schrödinger proposed the thought experiment as a criticism of the standard interpretation. He thought the implication that the cat could be in a superposition of dead and alive states was so absurd that it demonstrated the standard interpretation must be wrong. The thought experiment did not have the effect Schrödinger intended. Bohr and Heisenberg accepted the implication. The cat, on the standard quantum framework, is in a superposition of dead and alive states until the box is opened. The strangeness that Schrödinger took to be a reductio against the standard interpretation has turned out to be a feature of the physical world that contemporary physics has had to accommodate rather than dismiss. Subsequent experimental work has demonstrated that systems substantially larger than individual atoms can be placed in superposition states. The Austrian physicist Anton Zeilinger and his collaborators at the University of Vienna demonstrated across the past 2 decades quantum superposition in molecules of increasing size, with experiments in 2019 demonstrating superposition in molecules containing over 2,000 atoms. The systems are still very small compared to macroscopic objects like cats, but the experiments have established that the principle of superposition is not limited to the smallest subatomic scales. The question of where the boundary lies between systems that can be placed in superposition and systems that cannot has become one of the open questions in contemporary physics, with various proposed answers continuing to be debated. The question raises a deeper question about the relationship between the quantum framework that applies at the smallest scales and the classical framework that appears to apply at macroscopic scales. The relationship is one of the central problems in the foundations of physics. The various interpretations of quantum mechanics that we have been examining can be understood as different proposals for how to address this relationship. None of the proposals has been definitively established. The Christian theological tradition has articulated structurally similar frameworks across many centuries, with the question of how the divine reality relates to the apparent physical world being one of the central concerns of medieval and early modern Christian thought. The doctrine of analogia entis, the analogy of being, developed by Aquinas in the Summa Theologiae and elaborated across centuries of Catholic theology, holds that the relationship between divine being and created being is neither univocal nor equivocal, but analogical. The created world reflects the divine reality without being identical to it. The framework treats the apparent material world as participating in a deeper reality that is its source and ground, without being reducible to that deeper reality. The Hindu doctrine of Maya, articulated most fully in the Advaita Vedanta tradition by Shankara in the 8th century, articulates a structurally similar position. The apparent world of definite separate objects is, on this framework, Maya not illusion in the sense of being unreal, but appearance in the sense of being the surface manifestation of a deeper reality. The deeper reality, what the tradition calls Brahman, is what is genuinely real, with the apparent world being its specific local expression. The Buddhist tradition has articulated similar frameworks through the doctrine of the two truths developed by Nagarjuna in the 2nd century, which distinguishes between conventional truth, the level at which apparent objects appear to exist independently, and ultimate truth, the level at which the inherent independent existence of objects dissolves into the broader web of dependent origination. Whether the convergence between these traditional frameworks and the contemporary physics of measurement and superposition is meaningful, or whether it is structural coincidence between inquiries that are addressing very different questions in similar language, is a question that careful inquirers continue to engage. The question that Schrödinger's cat raises is the question of when, exactly, the quantum superposition collapses into a definite outcome. The standard Copenhagen interpretation, as Bohr articulated it, holds that the collapse occurs upon measurement. But what counts as a measurement? Is it the interaction with a measuring apparatus? Is it the registration of the result by a conscious observer? Is it something in between? The Hungarian-American physicist Eugene Wigner, who won the Nobel Prize in 1963, argued in his 1961 paper, Remarks on the Mind-Body Question, that the collapse requires a conscious observer. A measurement apparatus by itself, on Wigner's framework, would not collapse the wave function. The collapse would require the observation of the measurement by a conscious mind. Wigner illustrated his framework through a thought experiment that has become known as Wigner's friend. Imagine that a friend of yours is inside a sealed laboratory performing a quantum measurement. Until you are informed of the result, the entire laboratory, including your friend, is, on the standard quantum framework, in a superposition of states corresponding to the various possible measurement outcomes. But your friend, inside the laboratory, has presumably experienced a definite outcome. The thought experiment raises a question about whose consciousness collapses the wave function, your friend's or yours. The framework has been refined across the decades since Wigner first proposed it, with more recent versions including the Frauchiger-Renner thought experiment proposed in 2018 by Daniela Frauchiger and Renato Renner at ETH Zurich, which extends Wigner's framework into a paradox involving multiple observers making contradictory predictions about the same quantum system. The framework that Wigner was articulating, in which consciousness plays a specific role in determining what physical reality is, bears striking structural resemblance to what the great traditions have articulated through frameworks that hold consciousness to be fundamental rather than emergent. The Christian framework of creatio continua holds that without God's continuing awareness, the world would immediately return to nothingness, a position that bears striking, structural resemblance to Wigner's claim that without conscious observation, quantum systems would remain in superposed states rather than producing definite outcomes. The Hindu framework articulates similar positions through the doctrine that Brahman, the deeper consciousness, is the ground from which the apparent world of definite objects emerges. The Buddhist Yogacara framework articulates similar positions through its doctrine that all apparent phenomena are manifestations within consciousness. The Sufi tradition within Islam has articulated similar frameworks through the doctrine that the deeper reality of human consciousness is its participation in divine awareness, developed most fully by Ibn Arabi in the 13th century in his Futuhat al-Makkiyah. Each of these traditions developed its framework without any access to the experimental tools of contemporary physics. Each was working through the methods of sustained contemplative practice and careful philosophical reflection. Whether Wigner was articulating a framework that the physics actually requires, or whether he was importing philosophical categories that the physics permits but does not require, is a question that continues to be debated. The framework was controversial when Wigner proposed it, and has remained controversial. The dominant contemporary approach to understanding the measurement problem within mainstream physics is the decoherence framework, developed across the 1980s and 1990s through the work of Wojciech Zurek at Los Alamos and others. The framework holds that the apparent collapse of the wave function can be explained by the interaction of quantum systems with their environment, without requiring any specific role for consciousness. When a quantum system interacts with the vast number of degrees of freedom that constitute its environment, the photons in the room, the molecules of air, the thermal vibrations of nearby matter, the quantum coherence that allows superposition, is rapidly destroyed in a process that produces effectively classical behavior. The framework provides a mathematically rigorous account of why macroscopic objects like cats do not appear to exist in superposition states, while preserving the underlying quantum framework that the experimental work continues to confirm. The framework has become the dominant approach within mainstream physics, with Wigner's consciousness causes collapse interpretation being widely regarded as having been superseded. But the decoherence framework does not, by itself, settle the deeper interpretive question. The framework explains why macroscopic objects appear classical. It does not explain what happens to the various branches of the wave function that the framework treats as continuing to exist even after decoherence has rendered them practically inaccessible. The various interpretations of what happens to these branches, including the many worlds interpretation developed by Hugh Everett in his 1957 Princeton dissertation, in which all branches continue to exist as separate parallel realities, continue to be defended by serious physicists. The physics is documented. The interpretation is theoretical. What runs through all of these debates, from the original Solvay dispute to the contemporary work on decoherence, is the deeper question of what role observation and consciousness play in the constitution of physical reality. The question has not been settled. The question is more open than the materialist framework had assumed. The most sophisticated contemporary framework that takes the role of consciousness in quantum mechanics seriously is the orchestrated objective reduction theory, developed by the British mathematical physicist Roger Penrose and the American anesthesiologist Stuart Hameroff. Across the past several decades, Penrose, working at Oxford and winning the Nobel Prize in Physics in 2020 for his work on general relativity and black holes, he had argued in his books The Emperor's New Mind in 1989 and Shadows of the Mind in 1994 that consciousness involves features that no classical computational framework can adequately accommodate. The features include the apparent capacity of consciousness to engage with mathematical truths that are not algorithmically derivable from any specific set of axioms, the unified subjective character of conscious experience, and the specific temporal structure of consciousness. Hameroff, an anesthesiologist who had spent his career at the University of Arizona in Tucson, studying how anesthetics produce unconsciousness, proposed that microtubules within neurons might be the specific location where quantum processes that bear on consciousness take place. The collaboration produced a framework in which the moment-to-moment generation of conscious experience involves the orchestrated collapse of quantum states in microtubules through gravitational mechanisms at the fundamental level of physical reality. The framework has received empirical support across the past decade from the research of Anirban Bandyopadhyay at the National Institute for Materials Science in Japan, who has documented quantum coherent vibrations in microtubules in laboratory conditions, and from the 2024 research of Mike Wiest at Wellesley College on the effects of microtubule stabilizing anesthetics on consciousness in animal models. The framework remains controversial. The Swedish-American physicist Max Tegmark, working at MIT, published in 2000 an influential paper arguing that the kind of quantum coherence the framework requires could not be maintained in warm biological systems. The debate has continued, with the framework remaining contested but developing in response to empirical and theoretical challenges. The Heisenberg uncertainty principle, articulated by Werner Heisenberg in 1927, the same year as the Solvay Conference, establishes a different but related limitation on what physics can know about the quantum world. The principle emerged from Heisenberg's work in the summer of 1925, when he had retreated to the island of Helgoland in the North Sea to escape his hay fever and to work in solitude on the mathematical problems that quantum mechanics had been posing. The breakthrough that Heisenberg achieved on Helgoland, working alone through long sleepless nights, was the matrix formulation of quantum mechanics that would, within months, transform the entire field. He later wrote that he had the sensation, in the final hours before his work converged, of looking through the surface of phenomena to a structure of reality that was far stranger than any classical framework could accommodate. The uncertainty principle followed 2 years later from this initial breakthrough. The principle holds that certain pairs of physical properties, most famously position and momentum, cannot be simultaneously measured with arbitrary precision. The more precisely one is measured, the less precisely the other can be known. The limitation is not a feature of measurement instruments. The limitation is a feature of the physical world itself, expressing the fact that particles do not have simultaneously definite values for these complementary properties. The principle has been confirmed across decades of experimental work and forms one of the foundational features of quantum mechanics. The implications for the broader question of what physical reality is at its foundations have been substantial. If particles do not have simultaneously definite properties, then the classical picture of physical reality as consisting of objects with definite properties existing independently of measurement turns out to be inadequate to what the physics actually shows. The question that Heisenberg's principle raises is whether the indeterminacy is a feature of our knowledge of physical reality or a feature of physical reality itself. The standard interpretation, developed by Heisenberg and Bohr, holds that the indeterminacy is a feature of physical reality. Particles do not have hidden definite properties that the measurement merely reveals. The properties are genuinely indefinite until measurement. Other interpretations, including the Bohmian pilot wave framework, treat the indeterminacy as epistemic rather than ontological, with particles having definite properties that we cannot in principle determine through measurement. The interpretations have continued to be debated for nearly a century. None has been definitively established. What the uncertainty principle raises, beyond the technical question of what it means for measurement, is a deeper question about what physical reality is. If the properties of particles are genuinely indefinite until measurement, then the particles are not the kind of definite material objects that classical physics had assumed them to be. They are something stranger. They are something whose properties are constituted, at least in part, by the conditions of their measurement. The question of what they are, when not being measured, becomes one of the deeper questions of contemporary physics. The Buddhist tradition has articulated structurally similar positions for more than 2,000 years through the doctrine of pratitya samutpada, dependent origination, in which all phenomena lack inherent independent existence and arise only through their interrelationships. The framework was articulated most fully by the 2nd century philosopher Nagarjuna in his Mula-madhyamaka Karika, which argued through careful philosophical analysis that nothing has the kind of independent, definite existence that ordinary thinking attributes to physical objects. Nagarjuna's argument proceeded through a sustained examination of the concept of svabhava, inherent self-existence, demonstrating through philosophical analysis that nothing in the physical world has this kind of self-existence. The framework was developed across centuries of Buddhist philosophical reflection through the work of Aryadeva, Chandrakirti, and the broader Madhyamaka tradition. The framework has been one of the central insights of Buddhist thought and has influenced the development of philosophical and contemplative thought across Asia for nearly 2,000 years. The Hindu tradition has articulated related frameworks through its various schools of philosophy, particularly in the Advaita Vedanta tradition, where the apparent multiplicity of definite separate objects is understood as the appearance produced by the deeper underlying unity. The Christian mystical tradition has articulated similar frameworks through the negative theology developed by Pseudo-Dionysius, the Areopagite, in the 5th or 6th century, and elaborated across the medieval period, with the deeper divine reality being understood as exceeding any definite property that ordinary thinking might attribute to it. Whether the convergence between the Heisenberg framework and these ancient traditions is meaningful, or whether it is structural coincidence between very different inquiries operating in very different contexts, is a question that careful inquirers continue to engage. The popular discussions of quantum mechanics have often distorted what the physics actually shows. The popular framework that holds we create reality with our thoughts articulated through various books and films including The Secret by Rhonda Byrne and various works by Deepak Chopra and other popularizers, draws specific implications from the role of observation in quantum mechanics that the physics itself does not support. The physics shows that the act of measurement participates in determining the outcome of quantum experiments at the quantum scale. The physics does not show that conscious thoughts can directly create macroscopic physical events through quantum effects. The conditions under which quantum effects produce observable macroscopic phenomena are very specific and have been characterized in detail by decades of research. The popular framework that conflates these two very different positions does not survive careful examination. The framework has been criticized by serious physicists and philosophers across the past several decades, with critics, including the physicist Sean Carroll and the philosopher Massimo Pigliucci, articulating the various ways in which the popular framework distorts what the physics actually establishes. The careful position, which this documentary maintains throughout, is that contemporary physics has reopened questions about consciousness and reality without establishing any specific popular framework that has been built around the reopening. The reopening is genuine. The popular extensions of the reopening have often gone substantially beyond what the physics supports. What contemporary physics has actually established across the century since the Solvay conference is that the simple picture of an observer externally watching a physical reality that exists independently of the observation is not adequate to the documented phenomena that quantum experiments have revealed. The implications of this inadequacy for the deeper question of what reality is at its foundations have not been definitively settled. Various interpretations remain available, with the Copenhagen interpretation, the many worlds interpretation, the Bohmian pilot wave interpretation, the decoherence framework, the consistent histories interpretation, the Penrose-Hameroff framework, and various others continuing to be defended by serious physicists. Each interpretation has implications for the broader question of the relationship between consciousness and physical reality. Each has structural parallels in frameworks that the great philosophical and contemplative traditions have developed across millennia. None of the interpretations has been definitively established. None of the parallel frameworks has been definitively confirmed. What the careful inquirer can say with confidence is that the question is more open than the materialist framework had assumed, that contemporary physics has provided resources for thinking about the question that the merely classical framework could not provide, and that the great traditions of the world have articulated frameworks across millennia that bear striking structural resemblance to what contemporary physics is now suggesting in its various interpretations. The convergence is striking. The convergence is not proof. What follows from the convergence depends on what one brings to its interpretation. The next stage of the documentary will examine a question that bears directly on what we have been examining. If the observer participates in some fundamental sense in the constitution of physical reality, and if the properties of quantum systems are genuinely indefinite until measurement, what does this mean for the question of time? If consciousness plays some role in determining what reality is from moment to moment, what does this mean for the relationship between the past, present, and future that ordinary thinking treats as fundamental? These questions have been addressed by contemporary physics through the framework of special and general relativity, and they have been addressed by the great traditions across millennia through frameworks including the Christian doctrine of eternity, the Hindu framework of Brahman as beyond time, and the Buddhist framework of the deeper nature of consciousness as not subject to temporal succession. The convergences continue in this domain as in the others. The convergences continue to fall short of proof. What the convergences mean for the broader question of how to understand the situation in which we find ourselves is the question whose answer remains yours to develop rather than mine to provide. In March of 1955, 3 weeks before his own death, Albert Einstein learned that his closest lifelong friend Michel Besso had died in Italy. The two men had known each other since their student days in Zurich in the 1890s, where they had met at the Federal Polytechnic and discovered a shared passion for music, philosophy, and the foundations of physics. They had worked together at the Swiss Patent Office in Bern in the early years of the 20th century, When Einstein was developing the special theory of relativity that would transform the entire framework of physics, Bessel had been Einstein's primary intellectual sounding board during those years. Einstein's 1905 paper on special relativity, the paper that would change physics forever, was the only paper Einstein ever published that contained no references to previous work. The acknowledgement at the end of the paper credits a single person, Michel Bessel, whose careful questioning had helped Einstein clarify the framework that would emerge as special relativity. They had corresponded across the following 5 decades through wars, exiles, and the upheavals of 2 world wars. When Bessel died in late March of 1955, Einstein wrote to Bessel's sister and son a letter that has become one of the most quoted statements in the history of physics. "Now he is gone," Einstein wrote, "departing from this strange world a little ahead of me. That signifies nothing. For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion." Einstein himself would die 3 weeks later, on the 18th of April, 1955, in Princeton. The letter to Bessel's family articulates one of the most striking implications of the framework that Einstein had developed across the previous 50 years. The framework that emerged from special and general relativity, in one of its available interpretations, treats time itself as profoundly different from what ordinary experience suggests. The flow of time from past through present to future, on this interpretation, is not a feature of the underlying physical reality. It is a feature of how conscious beings within physical reality experience their own embedded position within a deeper structure in which past, present, and future are all equally real. The framework that Einstein was articulating in his letter to Bessel's family had been developed across the previous half-century through the work of multiple physicists and mathematicians. The crucial mathematical foundation had been provided by the German mathematician Hermann Minkowski in 1908, 3 years after Einstein had published his special theory of relativity. Minkowski had been Einstein's mathematics teacher at the Zurich Polytechnic, and he had originally regarded Einstein as one of the less promising students in his classes. When Einstein's special relativity paper appeared in 1905, Minkowski reportedly said that he could not have expected such mathematical depth from the lazy dog who had skipped his lectures. 2 years later, Minkowski himself developed the mathematical framework that would make the implications of special relativity accessible to physicists who had not previously been able to grasp them. In a lecture delivered at the 80th Assembly of German Natural Scientists and Physicians in Cologne in September of 1908, 3 months before his unexpected death from appendicitis at the age of 44, Minkowski announced that the views of space and time he was about to present had emerged from the soil of experimental physics. "Henceforth," he said, "space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality." The framework that Minkowski announced in that Cologne lecture, what is now called Minkowski spacetime, treats space and time as a single unified 4-dimensional structure rather than as separate categories. The implications, worked out across the following decades by Einstein and others, would transform our understanding of what time is. Minkowski did not live to see the full development of what his framework would enable. His sudden death 3 months after the Cologne lecture meant that the elaboration of his framework would be conducted by others, but the framework he had announced had already established the mathematical foundation on which the entire subsequent 20th century treatment of space and time would be built. The implications were articulated most explicitly through what philosophers of physics have come to call the block universe interpretation of relativity. The framework, developed across the 20th century through the work of Einstein and Minkowski, and elaborated philosophically through the work of various thinkers, including the American philosopher Hilary Putnam in his 1967 paper, Time and Physical Geometry, treats space-time as a 4-dimensional structure within which all of time exists with equal reality. The past has not ceased to exist. The future has not yet to come into existence. The past and the future are equally real with the present, with the apparent flow of time being a feature of conscious experience rather than a feature of the underlying physical structure. Putnam's specific argument, articulated in his 1967 paper, was that if simultaneity is relative, as special relativity requires, then events that are simultaneous in some reference frame are real in that frame, and therefore real simpliciter, regardless of whether they are simultaneous in any other frame. The argument implies that all events that are simultaneous with some observer somewhere are real, which when applied to the entire universe implies that all events at all times are real. The framework remains controversial among philosophers of physics. Various responses have been developed, with some philosophers arguing that the framework involves metaphysical extensions beyond what the physics strictly requires. But the framework is taken seriously by major physicists and philosophers. The framework is one available interpretation of the implications of relativity, not the only possible interpretation, but the broader debate continues to develop. The question of what time is, and whether the apparent flow of time corresponds to anything in fundamental reality, is not a question that originated with Einstein and Minkowski. The question has been one of the central questions of philosophical and contemplative inquiry across multiple traditions for more than 2,000 years. The most influential treatment of the question in the Western tradition appears in the 11th book of Augustine's Confessions, written around 398 inches Roman North Africa during the period when Augustine was Bishop of Hippo. Augustine begins his examination of time with what has become one of the most quoted passages in the history of philosophy. "What, then, is time?" he asks. "If no one asks me, I know. If I wish to explain it to someone who asks, I do not know." The examination that follows is one of the most sustained philosophical investigations of the nature of time in any tradition. Augustine argues that the past has ceased to exist, that the future does not yet exist, and that the present is an indivisible point with no duration. The implication, as Augustine works through it, is that time as ordinarily conceived seems to dissolve under careful analysis. If the past does not exist and the future does not exist, and the present has no duration, then what is it that we measure when we measure time? Augustine pursues this question through chapter after chapter of the Confessions, considering and rejecting various possible answers. He examines the idea that time is measured by the motion of the heavenly bodies, and rejects this on the grounds that even if the heavenly bodies stopped moving, time would presumably continue. He examines the idea that time is measured by some external standard, and rejects this on similar grounds. What Augustine ultimately concludes is that the deeper reality of time lies not in the external structure of the world, but in the conscious experience of the soul. The soul, Augustine argues, holds past, present, and future together through memory of the past, attention to the present, and expectation of the future. Time as we experience it is the distension of the soul across these three modes of awareness. The framework that Augustine developed across this book of the Confessions has been one of the most influential treatments of time in Western thought, with subsequent Christian theologians including Boethius, Aquinas, and modern philosophers continuing to engage with it across the centuries that followed. The framework anticipates in remarkable ways the contemporary recognition that the flow of time may be a feature of conscious experience rather than a feature of the underlying physical structure. The Christian theological tradition has developed Augustine's framework into what theologians have called the doctrine of eternity. The doctrine, articulated most fully by the 6th century Roman philosopher Boethius in his Consolation of Philosophy, distinguishes between eternity as the mode of divine existence and time as the mode of created existence. Boethius wrote the Consolation while awaiting execution in Pavia in 524, having been falsely accused of treason by the Ostrogothic king Theodoric. Boethius had been one of the most powerful figures in late Roman society, serving as consul and as principal minister to Theodoric, and had devoted his intellectual life to preserving the philosophical heritage of classical antiquity by translating Greek philosophical works into Latin. The accusation against him appears to have been politically motivated, with Boethius having defended a fellow senator against charges that Theodoric considered to be threats to his rule. The work, composed in his cell during the final months before his execution by torture, is one of the most influential philosophical texts in the history of Christianity. It takes the form of a dialogue between the imprisoned Boethius and Lady Philosophy, who appears to him in his cell to console him with philosophical reasoning. The fifth book of the Consolation addresses the question of how God's foreknowledge of future events is compatible with human freedom, and it is in this context that Boethius develops his framework of eternity. Boethius defines eternity as the simultaneously whole and perfect possession of unlimited life. Eternity is not infinite time. Eternity is a mode of existence in which there is no temporal succession, no past that has ceased to exist, no future that has not yet come, but only the complete presence of all that is real. God's relationship to time, on Boethius's framework, is that of eternity. God does not exist within time, but holds all of time within his eternal awareness, with all moments of time being equally present to him. The framework solves the problem of how divine foreknowledge is compatible with human freedom by treating the future as not foreknown in any temporal sense, but as directly present to the eternal divine awareness. The framework was elaborated by Aquinas in the Summa Theologiae across the 13th century, and has been one of the central frameworks within which Christian thought has addressed the question of time. The structural resemblance between the Boethian framework of eternity and the block universe framework of contemporary physics, despite the 14 centuries that separate them, is one of the more striking patterns in the broader history of human thought about time. Both frameworks treat the apparent flow of time as a feature of finite created experience rather than as a feature of the deeper reality. Both frameworks treat all moments of time as equally real at the deeper level. The frameworks differ in their specific theological commitments. They share the recognition that the simple picture of time as a flowing river from past through present to future is not adequate to the deeper structure of reality. The Hindu philosophical tradition has developed its own substantial framework for thinking about time across more than 3,000 years of careful reflection. The tradition distinguishes between two fundamental aspects of reality. Brahman, the deeper underlying reality, is held to be beyond time, beyond temporal succession, beyond beginning and ending. The apparent world of temporal succession, what the tradition calls samsara, is treated as the surface appearance of this deeper, timeless reality. The framework was developed in the Upanishads composed across centuries beginning around the 8th century before the Common Era, elaborated through the various schools of Hindu philosophy across subsequent millennia, and articulated with particular philosophical precision through the Advaita Vedanta tradition developed by the 8th century philosopher Shankara. The Bhagavad Gita, composed sometime between the 5th and 2nd centuries before the Common Era and incorporated into the Mahabharata, articulates this framework with particular directness in its 2nd chapter. The chapter addresses the question of death and the relationship between the eternal self and the temporal body. Arjuna, the warrior who is the protagonist of the Gita, has just refused to fight the upcoming battle because he cannot bear the thought of killing his own kinsmen who stand on the opposing side. Krishna, his divine charioteer, responds with a teaching that addresses the deeper nature of the self and its relationship to the body that will die in battle. The self, Krishna teaches, is never born and never dies. It is not slain when the body is slain. As a person abandons worn-out clothes and acquires new ones, so when the body is worn out, the self acquires another body. The framework that the Gita articulates treats the deeper self as participating in the timeless reality of Brahman, with the temporal succession of births and deaths being the appearance produced by the deeper timeless awareness expressing itself through specific embodied forms. The framework was elaborated across centuries by Hindu philosophers including Shankara, Ramanuja, Madhva, and the broader Vedantic tradition. The various schools developed different specific accounts of how the relationship between the temporal world and the timeless deeper reality should be understood. The schools differed in their specific theological commitments. They shared the recognition that the apparent flow of time is not the deepest level of reality. The framework has parallels with both the Boethian framework of eternity and the block universe framework of contemporary physics. Whether the convergence between these very different inquiries is meaningful, or whether it is structural coincidence between traditions addressing different questions in similar language, is a question that careful inquirers continue to engage. The Buddhist tradition has articulated its own substantial framework for thinking about time across more than 2,500 years. The framework operates within the broader Buddhist commitments about the nature of consciousness and the absence of a permanent self that persists across temporal succession. What persists, on the Buddhist framework, is not a soul in the Christian sense, but a continuity of consciousness that the tradition characterizes through specific philosophical vocabulary, including the Chittasantana, the stream of consciousness. The framework treats temporal succession as real at the conventional level of experience, but as not corresponding to the deeper structure of reality. The Mahayana tradition developed this framework with particular sophistication through the doctrine of bodhicitta, awakening mind, which is held to be not subject to the kinds of temporal limitations that ordinary consciousness experiences. The framework was elaborated across centuries by Buddhist philosophers, including Nagarjuna in the 2nd century, Asanga and Vasubandhu in the 4th century, and the broader Mahayana tradition. The Tibetan Buddhist tradition developed elaborate cosmologies involving vast temporal cycles called kalpas, with each kalpa lasting billions of years and being followed by other kalpas in an unending sequence. The framework treats the relationship between these vast temporal cycles and the deeper, timeless awareness in ways that bear striking structural resemblance to contemporary physical frameworks that treat ordinary temporal experience as the surface manifestation of a deeper structure. The Zen tradition, developing in China and Japan through the Chan and Zen schools beginning in the 6th century, has articulated similar positions through different vocabulary. The Japanese Zen master Dogen, writing in the 13th century in his work Shobogenzo, articulated a sophisticated philosophical framework in which what he called being time, uji, treats time and being as not two separate categories, but as different aspects of the same deeper reality. Dogen's framework anticipates in remarkable ways what contemporary physics in its various interpretations of time has begun to suggest. Whether the convergence between these ancient Buddhist frameworks and the contemporary physics of time is meaningful is, again, a question that no current research can definitively settle. The contemporary physics of time has developed in directions that neither Einstein nor the early framers of relativity could have anticipated. The Italian physicist Carlo Rovelli, working at the Center for Theoretical Physics in Marseille, has developed across the past 3 decades a framework that takes the implications of relativity even further than the standard block universe interpretation has. Rovelli's framework, articulated most fully in his 2017 book The Order of Time, argues that time is not a fundamental feature of physical reality at all. Time, on Rovelli's framework, emerges from the relations between physical systems rather than being a fundamental feature of the deeper structure. The world at its foundations, Rovelli argues, is not a series of events occurring in time, but is a network of relationships from which the appearance of temporal succession emerges as a derived phenomenon. The framework draws on Rovelli's earlier work with the American physicist Lee Smolin on what they have called loop quantum gravity, a theoretical framework that attempts to reconcile quantum mechanics with general relativity by treating space-time itself as quantized at the smallest scales. The framework has been developed across decades of mathematical work and continues to attract serious engagement from physicists and philosophers. Rovelli's broader articulation of the philosophical implications of this work, in books that have reached substantial popular audiences, including 7 Brief Lessons on Physics in 2014 and The Order of Time in 2017, has brought these implications into broader conversation. The framework has been controversial within philosophy of physics. The framework is one available interpretation of the implications of contemporary physics, not the only possible interpretation, but the framework has been developed with substantial mathematical rigor and continues to attract serious engagement from physicists and philosophers. What Rovelli is articulating bears striking structural resemblance to what the great traditions have been articulating for millennia. The Hindu framework that treats Brahman as beyond time articulates a position that the deeper reality is not temporal in the way ordinary experience suggests. The framework is developed most rigorously through the Advaita Vedanta tradition, with Shankara's 8th century commentaries on the Brahma Sutras articulating the position that what appears as temporal flow is the surface manifestation of a deeper, timeless awareness. The Buddhist framework articulates similar positions through its various formulations of the deeper nature of consciousness as not subject to temporal succession. The framework was developed most fully through the Madhyamaka tradition of Nagarjuna and through the Yogacara tradition of Vasubandhu and Asanga. The Christian framework of eternity articulates a related position in different vocabulary, with Boethius and Aquinas developing the framework across multiple centuries of theological reflection. The Taoist framework articulates similar positions through the broader concept of Tao as encompassing all temporal phenomena without itself being temporal. The Tao Te Ching, attributed to Laozi in the 6th century before the Common Era, articulates this framework through specific passages addressing the relationship between the temporal manifestations of phenomena and the deeper Tao from which they emerge. Whether the convergence between Ravelli's contemporary framework and these ancient traditions is meaningful, or whether the convergence is structural coincidence between very different inquiries operating in very different contexts, is a question that careful inquirers continue to engage. The Israeli-American physicist Yaakov Aharonov, working initially at Tel Aviv University and later at Chapman University in California, has developed across the past 60 years a framework that pushes the question of time in a different direction. Aharonov, who is best known for his 1959 discovery with David Bohm of what is now called the Aharonov-Bohm effect, demonstrating that electromagnetic potentials have physical reality at the quantum level, even where there are no electromagnetic fields, has continued across his career to develop frameworks that address the deeper structure of quantum mechanics. His work on what he calls weak measurements has demonstrated experimentally that quantum systems can exhibit behaviors that depend not only on their past, but also on their future. The framework, developed initially in 1964 inches, collaboration with Peter Bergman and Joel Lebowitz, and elaborated across subsequent decades, is called the two-state vector formalism. The framework treats quantum systems as characterized by both their initial state and their final state, with the behavior of the system between initial and final measurements depending on both. The work, conducted with various collaborators including Lev Weidman and Sandhu Popescu across multiple decades, has produced increasingly precise experimental demonstrations that the standard temporal ordering assumed by classical physics does not apply at the quantum level in the way ordinary thinking assumes. The framework has implications for what physicists have come to call retrocausality, the possibility that future events can influence past events through specific quantum mechanisms. The framework remains controversial. The framework is one available interpretation of the documented experimental phenomena, with various alternative interpretations continuing to be defended. The implications of the framework for the broader question of time have been substantial. If quantum mechanics allows for some form of retrocausal influence, then the temporal ordering that ordinary experience treats as fundamental may not be as fundamental as it appears. The question of what this means for the broader relationship between the past, present, and future remains one of the open questions in the philosophy of physics. The Christian tradition has articulated structurally similar positions through the doctrine that God's eternal awareness is not subject to temporal succession, with God's knowledge of the future not being a prediction of what will happen, but being a direct awareness of all moments, equally present in his eternal vision. The framework was developed by Boethius in the Consolation of Philosophy and elaborated by Aquinas in the Summa Theologiae, with its specific philosophical articulation being that God's knowledge of future contingent events is not foreknowledge in the strict temporal sense, but is direct awareness from the perspective of eternity. The framework has parallels in Hindu and Buddhist traditions that articulate the deeper consciousness as not subject to the temporal limitations that ordinary consciousness experiences. The popular discussions of time and quantum mechanics have often distorted what the physics actually shows. The popular framework that holds that the block universe interpretation of relativity supports the practice of manifestation, the position that we can shape future events by visualizing them in the present, articulated through various popular books and films, including The Secret by Rhonda Byrne and various works by Deepak Chopra and other popularizers, draws specific implications from the block universe framework that the framework itself does not support. The block universe framework, if it is correct, holds that the future is as real as the present. The framework does not hold that conscious thoughts in the present can shape what the future contains. The framework holds that what the future contains is already determined in the deeper structure of space-time, regardless of what conscious beings within space-time visualize or wish for. The popular framework that confuses these two very different positions does not survive careful examination. Similarly, the popular framework that treats retrocausality as supporting the practice of changing past events through present intentions distorts what the contemporary physics of retrocausality actually shows. The Aharonov framework, even on its most generous interpretation, does not establish that conscious intentions in the present can rewrite past events. The framework establishes that the temporal ordering of quantum events is more subtle than classical physics had assumed, with measurements taking place under specific conditions affecting what can be said about prior events. These two positions are very different. The popular conflation does not survive careful examination. The framework has been criticized by serious physicists and philosophers across the past several decades, with critics including the physicist Sean Carroll articulating the various ways in which the popular framework distorts what the physics actually establishes. The careful position, which this documentary maintains throughout, is that contemporary physics has reopened questions about the nature of time without establishing any specific popular framework that has been built around the reopening. The reopening is genuine. The popular extensions have often gone substantially beyond what the physics supports. The convergence between contemporary physics and the great traditions on the question of time deserves particular attention because of how striking it is. The Boethian framework of eternity, developed in a cell in Pavia in 524 awaiting execution, anticipates in remarkable ways what contemporary physics, in its various interpretations of relativity, has suggested. The Hindu framework of Brahman as beyond time, developed across millennia of philosophical refinement, anticipates similar positions. The Buddhist framework of the deeper nature of consciousness as not subject to temporal succession articulates structurally parallel positions through different vocabulary. The Taoist framework of Tao as encompassing all temporal phenomena without itself being temporal articulates similar positions. The Augustinian framework, developed in late Roman North Africa around 398, anticipates in equally remarkable ways what contemporary phenomenology and philosophy of mind have suggested about the role of conscious experience in constituting our sense of temporal flow. The frameworks were developed without any access to the experimental tools of contemporary physics. The frameworks were developed by inquirers who were addressing what they took to be deep questions about the structure of reality, using the methods of contemplative practice and philosophical reflection rather than the methods of laboratory measurement. The structural resemblance between what these ancient inquirers articulated and what contemporary physics has begun to suggest is one of the more striking patterns in the history of human thought. The resemblance does not establish that the ancients knew what contemporary physics is now discovering. The resemblance establishes that the questions are old, that careful inquirers across many centuries have addressed them with serious philosophical and contemplative resources, and that contemporary physics is one specific contribution to a much older inquiry, rather than a complete replacement of what came before. What Einstein wrote in his letter to the Bessot family in March of 1955 articulates the implication that the framework he had developed had for him personally. The distinction between past, present, and future is, for us believing physicists, only a stubbornly persistent illusion. Whether the implication is correct, or whether Einstein was overstating what the physics actually requires, is a question that has continued to be debated across the 70 years since the letter was written. What the letter establishes is that one of the most important physicists of the 20th century, working within the framework that he himself had developed, was led to a position about the nature of time that bears striking structural resemblance to positions that the great traditions have articulated for millennia. The position is not unique to Einstein. Schrödinger had articulated structurally similar positions through his engagement with Vedanta. Bohm had articulated similar positions through his framework of the implicate order. Wheeler had articulated similar positions through his framework of the participatory universe. Ravelli has articulated similar positions through his framework of relational time. Aharonov has articulated related positions through his framework of two-state vectors and weak measurements. The convergence across these various contemporary physicists, with each of them being led by their own work to positions that the great traditions had been articulating for millennia, is one of the more striking patterns in the broader development of 20th and 21st century thought. The position is also not unique to physics. The contemporary phenomenology of time, developed by philosophers including Edmund Husserl in the early 20th century and Maurice Merleau-Ponty in the mid-20th century, has articulated structurally similar positions about the constitution of temporal experience through conscious awareness. Whether the convergence reflects something genuine about the structure of reality, or whether it reflects the specific philosophical preferences that physicists and philosophers have brought to their interpretations of the underlying phenomena, is the question whose answer remains yours to develop, rather than mine to provide. The next stage of the documentary will examine a question that bears directly on what we have been examining in this stage. If time itself is not what ordinary experience suggests, what does this mean for the relationships that persist across time? What does it mean for the connections between conscious beings that ordinary thinking treats as separated by space and by temporal succession? The contemporary physics of quantum entanglement, developed across the past century through the work of Einstein, Bohr, Bell, Aspect, and others, has revealed structural features of physical reality that suggest the apparent separation between distant beings is not as fundamental as ordinary experience indicates. The frameworks have parallels in traditions that have articulated the fundamental connectedness of all conscious beings. Through frameworks including the Christian doctrine of the mystical body of Christ, the Hindu doctrine of Advaita, the Buddhist framework of dependent origination and Indra's net, and the Taoist framework of Dawa as the underlying unity of all phenomena. The convergences continue in this domain, as in the others. The convergences continue to fall short of proof. What the convergences mean for the broader question of how to understand the situation in which we find ourselves is the question whose answer remains yours to develop, rather than mine to provide. In 1935, 3 years after Einstein had been awarded the Nobel Prize, and 4 years after the publication of Heisenberg's uncertainty principle, had completed the basic mathematical framework of quantum mechanics, Einstein published with his colleagues Boris Podolsky and Nathan Rosen a paper that would become one of the most consequential documents in the history of physics. The paper, published in the Physical Review and titled "Can Quantum Mechanical Description of Physical Reality Be Considered Complete?", was intended by Einstein as a final demonstration that the standard interpretation of quantum mechanics must be incomplete. The argument that Einstein, Podolsky, and Rosen developed has come to be known as the EPR paradox. The argument proceeded by considering what happens when two particles are produced together in such a way that their quantum states are correlated. The standard framework of quantum mechanics, as developed by Bohr and Heisenberg, held that the properties of these particles are not definite until measurement. If the particles are then separated and one of them is measured, the measurement of the first particle would seem to instantaneously determine the properties of the second particle, regardless of how far apart they have become. Einstein found this implication absurd. He called it spookhaft Fernwirkung, spooky action at a distance. The framework that allowed such instantaneous coordination across arbitrary distances must, Einstein argued, be incomplete. There must be hidden variables that the framework had not yet identified, variables that determined the properties of the particles all along, and that the measurement merely revealed. The EPR paper was intended as a knockout argument against the standard interpretation of quantum mechanics. The paper did not have the effect Einstein intended. Bohr responded to the paper with his own analysis, arguing that the standard interpretation could accommodate the EPR scenario without requiring hidden variables. The debate between Einstein and Bohr continued through the remaining 2 decades of Einstein's life without resolution. The deeper question that the EPR paper had raised, however, was whether the apparent connectedness of separated quantum particles was a genuine feature of physical reality, or whether it reflected our incomplete knowledge of underlying hidden variables. The question would not be experimentally addressable for nearly 3 decades. When it finally became experimentally addressable, the answers would prove more striking than anyone in 1935 had anticipated. The German term that Schrödinger introduced for the phenomenon of quantum correlations between separated particles was Verschränkung, which has been translated into English as entanglement. Schrödinger introduced the term in a 1935 paper responding to the EPR argument, and he characterized entanglement as not one but rather the characteristic trait of quantum mechanics, the one that enforces its entire departure from classical lines of thought. The framework that Schrödinger was articulating treated entanglement as a fundamental feature of the quantum world rather than as a derivative phenomenon that could be reduced to other principles. 2 particles that had interacted in the past, on Schrödinger's framework, would remain in a single combined quantum state across arbitrary distances, with the measurement of one particle's properties immediately affecting what could be said about the other particle's properties, regardless of the spatial separation between them. The framework was strange. The framework violated something fundamental about how classical physics had understood the relationship between locality and causation. Particles separated by vast distances were not supposed to be able to influence each other faster than the speed of light. Einstein's special relativity had established this principle as one of the foundational features of physical reality, and yet quantum mechanics, in its standard interpretation, seemed to allow exactly this kind of faster-than-light coordination between separated particles. The question of how this could be was one of the central puzzles of 20th century physics. The question that the EPR paper raised, of whether the apparent connectedness of separated quantum particles reflects a genuine feature of physical reality or reflects our incomplete knowledge, was not addressable experimentally until 1964. In that year, the Northern Irish physicist John Stuart Bell, working at CERN in Geneva, published a paper titled On the Einstein-Podolsky-Rosen Paradox that transformed the question from a philosophical puzzle into an experimental one. Bell had been working at CERN as a theoretical physicist whose primary research was on the design of particle accelerators. The work on the foundations of quantum mechanics that produced his theorem was conducted in his free time as a personal intellectual interest that his colleagues regarded with some skepticism. Bell was sympathetic to Einstein's position. He thought the standard interpretation of quantum mechanics must be incomplete, and he hoped that careful mathematical analysis would reveal where the framework was inadequate. The paper he produced, written during a sabbatical year at Stanford and Brandeis in 1964, proved a mathematical theorem that has come to be known as Bell's theorem. The theorem demonstrates that any hidden variable theory that satisfies the kinds of locality conditions that classical physics had assumed must produce experimental predictions that differ from the predictions of standard quantum mechanics. The theorem provides specific mathematical inequalities, now called Bell inequalities, that must be satisfied by any theory consistent with local hidden variables. If experimental measurements violate these inequalities, then local hidden variables cannot explain the results. The theorem was extraordinary in its implications. It transformed the question of whether quantum mechanics required spooky action at a distance from a philosophical question into a question that experimental measurement could settle. Bell himself was hoping, when he proved his theorem, that careful experimental measurements would probably reveal that quantum mechanics was incomplete and that local hidden variables would be vindicated. The experimental results, when they began to come in across the following decades, would show otherwise. Bell would live to see the early experimental work, including the aspect experiments of the early 1980s, but he died in 1990 at the age of 62 from a cerebral hemorrhage before the broader research program had reached the level of experimental precision that would eventually result in the 2022 Nobel Prize. The experimental work that addressed Bell's inequalities began in the 1970s through the work of the American physicist John Clauser, who designed the first experimental tests of Bell's theorem with his collaborator Stuart Friedman at Berkeley. The Clauser-Friedman experiments, conducted in 1972, provided the first experimental evidence that quantum mechanics was producing the kinds of correlations between separated particles that Bell's theorem identified as inconsistent with local hidden variables. The experiments were technically challenging, and the results, while consistent with quantum mechanics, were not yet definitive enough to settle the broader question. The work that produced definitive results came from the French physicist Alain Aspect, working at the Institut d'Optique in Orsay, outside Paris in the early 1980s. Aspect had completed his doctoral dissertation on the foundations of quantum mechanics in 1983, focusing specifically on the experimental tests of Bell's theorem that he had been conducting across the previous several years. His experiments, conducted between 1980 and 1982, with his collaborators Philippe Granger and Jean Dalibard, used pairs of photons produced by an excited calcium source and measured the correlations between their polarizations under conditions that closed various loopholes that earlier experiments had left open. The most striking version of the experiment, conducted in late 1982, used what Aspect called fast switching, in which the choice of which property to measure on each photon was made after the photons had already left the source. The fast switching ensured that the choice could not have been communicated to the source through any signal traveling at or below the speed of light. The choice was made by acousto-optical switches operating at frequencies in the megahertz range, with the switching occurring during the time it took the photons to travel from the source to the detectors. The results were unambiguous. The correlations that Aspect measured violated Bell's inequalities by margins that ruled out local hidden variables. Quantum mechanics was producing exactly the kinds of non-local correlations that Einstein had found absurd, and the framework that Einstein had proposed as an alternative was not consistent with what nature actually does. Aspect's experiments were not the final word. Various loopholes remained, particularly what physicists called the detection loophole, the possibility that the particles being detected were not a representative sample of all the particles being produced. The closing of these remaining loopholes would take another 3 decades of careful experimental work, but the Aspect experiments established that local hidden variables could no longer be defended on the basis of the empirical evidence, and that the non-locality of quantum mechanics was a feature of physical reality rather than an artifact of the framework. The Aspect experiments did not end the broader research program. Subsequent experiments have continued to refine the tests and close remaining loopholes. The work of the Austrian physicist Anton Zeilinger, working at the University of Vienna across the past 3 decades, has produced increasingly sophisticated tests of quantum non-locality, including experiments demonstrating entanglement between particles separated by distances of hundreds of kilometers and using astronomical sources to generate the random choices that govern the measurement settings. Zeilinger's experiments in 2017 used light from quasars, billions of light years away, to determine the measurement settings, ruling out the possibility that the correlations could be explained by any local hidden variables that had been in causal contact with both the source and the detector since the early universe. The work of the American physicist John Clauser, who had begun the experimental investigation of Bell's theorem in the early 1970s, has continued in parallel with the development of the broader field. In October of 2022, the Nobel Prize in Physics was awarded to Aspect, Clauser, and Zeilinger for what the Nobel Committee described as their experiments with entangled photons, establishing the violation of Bell inequalities and pioneering quantum information science. The award represented a recognition, nearly a century after Einstein had first articulated the EPR paradox, and nearly 6 decades after Bell had transformed it into an experimental question, that the strange features of quantum mechanics that Einstein had found impossible to accept are features of physical reality that experimental measurement has now demonstrated with substantial precision. The framework of quantum mechanics, in the broader interpretation that Bohr had defended against Einstein, is not incomplete in the way Einstein had thought. The non-locality is real. The correlations between separated quantum particles exceed what any local theory can produce. What this means for the broader question of the relationship between separated parts of physical reality is one of the open questions of contemporary physics. The question of what quantum non-locality actually means for the structure of reality is not a question that contemporary physics has settled. Various interpretations remain available. The Copenhagen interpretation treats the non-local correlations as features of physical reality that emerge from the act of measurement, with the deeper question of how the correlations arise being treated as not addressable by physics. The many worlds interpretation treats the correlations as arising from the branching of the universe at each measurement, with the different outcomes being realized in different branches. The Bohmian pilot wave interpretation treats the correlations as arising from a non-local quantum potential that connects all parts of physical reality. The Penrose-Hameroff framework treats the correlations as arising from quantum processes that operate at the fundamental level of space-time. None of these interpretations has been definitively established. The physics is documented, the non-locality is real, the interpretation is theoretical. The question that quantum non-locality raises, of whether the apparent separation between distant parts of physical reality is as fundamental as ordinary experience suggests, is not a new question. The great philosophical and contemplative traditions of the world have addressed this question for more than 2,000 years through frameworks that articulate the fundamental connectedness of all phenomena. The Buddhist tradition has articulated this framework with particular philosophical precision through the doctrine of pratitya samutpada, dependent origination, developed initially by the historical Buddha in the 5th century before the Common Era, and elaborated across subsequent centuries by the Madhyamaka tradition of Nagarjuna in the 2nd century and the broader Mahayana tradition. The framework holds that no phenomenon has independent existence. Everything arises in dependence on other things, with the apparent independent existence of separate objects being the appearance produced by patterns of conventional understanding rather than a feature of the deeper structure of reality. Nagarjuna's articulation of this framework in his Mula Madhyamaka Karika proceeded through a sustained philosophical analysis of the concept of svabhava, inherent self-existence, demonstrating that nothing in the physical world has the kind of independent, definite existence that ordinary thinking attributes to physical objects. The framework was developed across centuries of Buddhist philosophical reflection through the work of Aryadeva, Chandrakirti, and the broader Madhyamaka tradition. The framework was elaborated with particular vividness in the Huayan school of Chinese Buddhism, developed in the 7th century through the work of the patriarchs Fazang and Chengguan. The Huayan tradition was based on the Avatamsaka Sutra, the Flower Garland Sutra, which is one of the longest and most philosophically sophisticated texts in the Mahayana Buddhist canon. The sutra was composed in India over several centuries, beginning around the 2nd century of the Common Era, and was translated into Chinese across the 4th through 8th centuries. The Huayan school developed an elaborate philosophical framework based on the sutra that articulated the structural interconnectedness of all phenomena through several specific philosophical formulations. The most famous image developed within the Huayan tradition was that of Indra's net. Indra's net, as the Huayan tradition describes it, is an infinite cosmic web of interconnected jewels, with each jewel reflecting every other jewel in the entire web. Each jewel contains within itself the reflections of all the others, with the others in turn containing within themselves reflections of each jewel, in an infinite mutual containment that the tradition uses to articulate the structural interconnectedness of all phenomena. Fazang, in his famous essay on the Golden Lion, composed for Empress Wu Zetian of the Tang dynasty around 700, used the image to articulate how every part of reality contains and is contained by every other part. The framework has been one of the central images in the Hawaiian tradition and has influenced the development of Buddhist thought across East Asia for more than 14 centuries. With subsequent traditions including Korean Zen Buddhism and Japanese Kegon Buddhism continuing to develop the framework through their own specific elaborations. The structural resemblance between Indra's net and the non-local correlations that contemporary physics has now experimentally demonstrated is one of the more striking patterns in the broader history of human thought about the connectedness of physical reality. Whether the convergence is meaningful, or whether it is structural coincidence between very different inquiries, operating in very different contexts, is a question that no current research can definitively settle. The Hindu philosophical tradition has articulated structurally parallel positions through the doctrine of Advaita, non-duality, developed most fully in the Advaita Vedanta tradition by the 8th century philosopher Shankara. Shankara had been born in southern India around 788 and had developed his philosophical system through extensive commentaries on the Upanishads, the Brahma Sutras, and the Bhagavad Gita. His framework holds that the apparent multiplicity of separate beings and separate objects is the surface manifestation of a deeper underlying unity, what the tradition calls Brahman. Shankara's framework treats the apparent separateness of individual conscious beings as Maya, appearance, with the deeper reality being the non-dual awareness in which all apparent distinctions dissolve. The framework articulates the position through the famous Mahavakyas, the great sayings of the Upanishads, including Tattvam Asi, that thou art, articulated in the Chandogya Upanishad, and Aham Brahmasmi, I am Brahman, articulated in the Brihadaranyaka Upanishad. These statements articulate the position that the deeper consciousness of the individual being is identical with the deeper reality of Brahman, with the apparent separation between the individual self and the broader cosmic reality being the appearance produced by Maya. The framework was elaborated across centuries by Hindu philosophers including Sureshvara, Padmapada, Vakaspati Mishra, and the broader Advaita tradition. The framework has parallels with the Buddhist doctrine of dependent origination, despite the substantial theological differences between the two traditions. The Buddhist tradition does not accept the framework of a deeper unified consciousness that the Advaita tradition affirms. The Advaita tradition does not accept the Buddhist doctrine of the absence of a permanent self. The frameworks differ in their specific theological commitments. They share the recognition that the apparent separation between distinct beings is not as fundamental as ordinary experience suggests, and that careful philosophical analysis reveals deeper connectedness that ordinary perception cannot directly access. The frameworks anticipate in remarkable ways what contemporary physics has now experimentally demonstrated about the non-local correlations between separated quantum systems. The Christian theological tradition has articulated structurally similar frameworks through what theologians have called the doctrine of the mystical body of Christ. The doctrine, developed initially through the letters of Paul in the 1st century, articulates a vision in which all baptized Christians are not merely associated with each other through shared belief, but are members of a single mystical body whose head is Christ. The Pauline articulation appears most fully in the 12th chapter of the first letter to the Corinthians, in which Paul develops the metaphor of the body and its members in detail, arguing that just as the body has many members that share a common life, so do the members of the church share a common life that exceeds what their apparent individual existence would suggest. The framework was developed across 2,000 years of Christian theological reflection, with elaborations through the work of Augustine in his sermons and his commentary on the Psalms in the 5th century, Aquinas in his treatment of the Eucharist and the mystical body in the 3rd part of the Summa Theologiae across the 13th century, and various 20th century theologians, including the Belgian Cardinal Joseph Mercier in the early 20th century and Pope Pius XII, who articulated the doctrine in his 1943 encyclical Mystici Corporis Christi. The encyclical, issued during the Second World War as the Catholic Church confronted the violent fragmentation of European Christendom, articulated the framework with particular philosophical depth, arguing that the connections between members of the body are genuinely metaphysical rather than merely social. The framework treats the apparent separation between individual Christians as the surface manifestation of a deeper unity that participates in the divine being through Christ. The framework has parallels in the broader Christian doctrine of the communion of saints, which holds that all who have died in Christ remain part of a single communion with those who are still living. Both doctrines articulate the position that the apparent separation between distinct persons is not as fundamental as ordinary experience suggests, and that careful theological reflection reveals deeper connectedness that ordinary perception cannot directly access. The Orthodox Christian tradition has developed parallel frameworks through its theology of synergy and divine communion, articulated most fully through the work of the 7th century Byzantine theologian Maximus the Confessor, and elaborated across centuries of Eastern Christian thought. Whether the convergence between these Christian frameworks and the contemporary physics of quantum non-locality is meaningful, or whether the convergence is structural coincidence, is a question that careful inquirers continue to engage. The Taoist tradition has articulated similar frameworks through the broader concept of Tao as the underlying unity of all phenomena. The framework was developed most fully through the Tao Te Ching attributed to Laozi in the 6th century before the Common Era, and elaborated extensively in the writings of Zhuangzi in the 4th century before the Common Era. The Tao, on this framework, is not a being separate from the phenomena it produces, but is the underlying pattern of all manifestation, with the apparent separateness of individual phenomena being the surface expression of the deeper unity of Tao. The Sufi tradition within Islam has articulated similar frameworks through the doctrine of Wahdat al-Wujud, the unity of being, developed most fully by Ibn Arabi in the 13th century in his major work, the Futuhat al-Makkiyah. The framework holds that all apparent multiplicity is the surface manifestation of the deeper unity of divine being, with the apparent separateness of individual beings being the appearance produced by their participation in the deeper reality. Each of these traditions developed its framework without any access to the experimental tools of contemporary physics. Each was working through the methods of sustained contemplative practice and careful philosophical reflection across many centuries. Each arrives at frameworks that bear striking structural resemblance to what contemporary physics has now demonstrated about the non-local correlations between separated quantum systems. The most sophisticated contemporary physical framework that takes the implications of quantum non-locality seriously is the implicate order theory developed by the British physicist David Bohm. The framework, articulated most fully in Bohm's 1980 book Wholeness and the Implicate Order, proposes that the physical reality we ordinarily encounter is an unfolding of a deeper underlying reality through processes that operate according to specific structural principles. Bohm had developed his initial framework for understanding quantum mechanics in his 1952 papers on what he called the pilot wave theory, which provided a deterministic alternative to the standard Copenhagen interpretation. The pilot wave theory treated particles as having definite positions at all times, with their behavior being guided by what Bohm called a quantum potential that operates non-locally across the entire system. The framework was substantially developed during the 1970s after Bohm's engagement with the broader questions about consciousness and reality that the Indian philosopher Jiddu Krishnamurti had been raising in his teachings. Bohm conducted across more than 2 decades a series of dialogues with Krishnamurti that addressed the relationship between contemporary physics and the question of consciousness. The dialogues, recorded across the 1970s and 1980s and published in various volumes including The Ending of Time, shaped the philosophical articulation of the implicate order framework that Bohm developed across these decades. The implicate order is, on the framework, the level at which information is distributed across the entire system in a holographic manner, with specific manifestations in the explicate order being unfoldings of patterns that exist in compressed form at the deeper level. The framework treats the apparent separation between objects in the explicate order as itself a feature of how the explicate order operates, rather than a feature of the deeper implicate order. At the implicate level, all phenomena are interconnected in ways that the explicate level cannot fully capture. The explicate level is, on the framework, a kind of unfolding of patterns that exist in compressed form at the implicate level, with the explicate manifestations being temporary expressions of the deeper patterns rather than the basic level of reality. The framework treats this unfolding and enfolding as a continuous process that Bohm called the Hollow movement, with the Hollow movement being the fundamental process from which all specific phenomena emerge. The Bohm framework provides a contemporary scientific framework within which the non-locality demonstrated by Bell's theorem and the aspect experiments can be understood as a feature of the deeper structure of reality rather than as a puzzling anomaly that requires special explanation. The framework remains controversial within mainstream physics, but it continues to be developed and to attract serious engagement from physicists and philosophers. The framework has been particularly influential in the work of contemporary physicists, including Basil Hiley, who worked with Bohm at Birkbeck College in London across decades, and who has continued to develop the framework since Bohm's death in 1992. The popular discussions of quantum entanglement have often distorted what the physics actually shows. The popular framework that holds that quantum entanglement supports the practice of romantic soulmate connections, the position that two persons can be quantum mechanically entangled with each other in ways that allow them to communicate instantaneously across distances or to share emotional experiences, draws specific implications from the entanglement framework that the framework itself does not support. The physics demonstrates that pairs of particles produced together in specific ways can remain correlated across arbitrary distances. The physics does not demonstrate that the human beings who carry these particles within them can communicate with each other through such correlations, or that emotional bonds between people are quantum mechanically entangled in any technical sense. The conditions under which quantum entanglement produces observable correlations are very specific. The entanglement requires that the particles have a common origin in a process that produces the correlation. The entanglement is degraded by interaction with the environment, a process called decoherence that we have examined in connection with the measurement problem. The conditions are not met by anything resembling ordinary emotional connections between human beings. The popular framework that conflates these very different phenomena does not survive careful examination. Similarly, the popular framework articulated through various works by Deepak Chopra and other popularizers that holds that quantum entanglement supports the practice of quantum healing, the position that conscious intentions can heal physical illness through quantum mechanisms operating across distance, draws specific implications from entanglement that the physics itself does not support. The physics does not establish that conscious intentions in one location can affect physical processes in another location through quantum mechanisms. The popular framework that conflates the technical phenomenon of entanglement with broader claims about healing or interpersonal connections has been criticized by serious physicists and philosophers across the past several decades, with critics including the physicist Sean Carroll, the philosopher Massimo Pigliucci, and the medical researcher Stephen Barrett articulating the various ways in which the popular framework distorts what the physics actually establishes. The criticisms have not eliminated the popular framework, which continues to appear in books and websites that draw substantial popular audiences, but the criticisms have established that the popular framework cannot be defended on the basis of careful engagement with the actual physics. The careful position, which this documentary maintains throughout, is that contemporary physics has demonstrated the reality of non-local correlations between properly entangled quantum systems without establishing any specific popular framework that has been built around this demonstration. The non-locality is genuine. The popular extensions have often gone substantially beyond what the physics supports. What contemporary physics has established across the 9 decades since the EPR paper is that the apparent separation between distant parts of physical reality is not as fundamental as classical physics had assumed. The non-local correlations that Einstein had found absurd are features of physical reality that experimental measurement has now demonstrated with substantial precision. What this means for the broader question of the structure of reality at its foundations is something that contemporary physics has not definitively settled. Various interpretations remain available, with each having implications for the deeper question, and each having structural parallels in the frameworks that the great traditions have articulated across millennia. The Buddhist framework of dependent origination and Indra's net articulates structurally parallel positions through the methods of contemplative philosophical analysis. The Hindu framework of Advaita articulates similar positions through the Vedantic tradition. The Christian framework of the mystical body of Christ articulates related positions in different vocabulary. The Taoist framework of Tao articulates similar positions through the broader cosmological framework of Chinese philosophy. The Sufi framework of Wada al-Wujud articulates similar positions within the broader Islamic philosophical tradition. The convergence across these various ancient and contemporary frameworks is striking. The convergence is not proof. What follows from the convergence depends on what one brings to its interpretation. The next stage of the documentary will examine a question that bears directly on what we have been examining. If everything is fundamentally connected in ways that exceed what ordinary perception suggests, and if the apparent separation between distant beings is not as fundamental as classical physics had assumed, what does this mean for the question of what happens to information at death? If the deeper structure of reality is one of fundamental interconnectedness, does the information that constitutes a conscious individual simply cease at biological death, or does it persist in some form within the deeper, interconnected reality? These questions have been addressed by contemporary physics through the framework of black hole information conservation, developed across decades of work by Hawking, Susskind, Hooft, and Maldacena. They have been addressed by the great traditions across millennia through frameworks, including the Christian doctrine of the immortality of the soul, the Hindu doctrine of the eternal Atman, the Buddhist framework of the Bardo states through which consciousness passes after biological death, and the Taoist framework of the broader transformation of phenomena within Tao. The convergences continue in this domain as in the others. The convergences continue to fall short of proof. What the convergences mean for the broader question of how to understand the situation in which we find ourselves is the question whose answer remains yours to develop rather than mine to provide. In the winter of 1974, the British theoretical physicist Stephen Hawking, working at the University of Cambridge, published a paper in the journal Nature that would transform the understanding of black holes and would raise one of the deepest questions in contemporary physics. The paper, titled simply Black Hole Explosions, demonstrated that black holes are not the perfect cosmic prisons that earlier physics had assumed them to be. Hawking had been examining what happens when quantum mechanical processes are applied to the regions just outside black hole event horizons. The classical framework of general relativity, developed by Einstein in 1915, had treated black holes as objects from which nothing could escape, with anything that crossed the event horizon being permanently captured by the gravitational field. Hawking had been working on the broader theory of black holes since the early 1960s, when as a young graduate student he had been diagnosed with the motor neuron disease that would gradually limit his physical capacities across his subsequent 5 decades. The work on black hole thermodynamics that produced his 1974 paper had been conducted across the previous several years in collaboration with his colleagues, Jacob Bekenstein at Princeton, Brandon Carter at Cambridge, and others. The framework that emerged treated black holes as objects with specific thermodynamic properties including temperature and entropy, with the entropy being proportional to the surface area of the event horizon. The Israeli-American physicist Jacob Bekenstein had proposed in 1972 that black holes must have entropy in order to be consistent with the second law of thermodynamics. Hawking initially resisted Bekenstein's argument, but was led across the following 2 years to the discovery that black holes are not perfect absorbers, but emit radiation through quantum processes operating in the regions just outside the event horizon. The quantum mechanical framework, when applied to the regions just outside the horizon, revealed that black holes must in fact emit radiation. The radiation, what is now called Hawking radiation, carries energy away from the black hole. The black hole, as a consequence, gradually loses mass and eventually evaporates entirely across timescales that depend on its initial size. For a black hole of stellar mass, the evaporation timescale is longer than the current age of the universe by many orders of magnitude. For microscopic black holes that might have been produced in the early universe, the evaporation timescale could be short enough that the evaporation would have already occurred. The discovery was extraordinary in its implications. It established that black holes are not eternal. They are temporary structures that exist for vast but finite periods of time before evaporating completely into radiation that disperses across the broader universe. The discovery also raised a question that has come to be known as the black hole information paradox. The radiation that emerges from an evaporating black hole, on Hawking's original analysis, contains no information about what fell into the black hole. The information appears to be permanently destroyed when the black hole evaporates. The implications would shape one of the central debates in theoretical physics across the following 5 decades, with Hawking himself eventually conceding in 2004 that information is most likely conserved across the evaporation process. Contrary to his original 1974 conclusion, the question of what happens to information at death is not a new question. The great philosophical and contemplative traditions of the world have addressed this question for more than 2,000 years through frameworks that articulate the relationship between physical death and the deeper continuation of what constitutes a conscious being. The question of whether what we are at our deepest level is the kind of thing that can be destroyed by biological death, or whether it persists in some form beyond biological death, has been one of the central questions of human inquiry across multiple traditions. The black hole information paradox raises this question in a specific contemporary form. If physical information can be permanently destroyed when a black hole evaporates, then the broader question of whether information about a conscious being persists beyond biological death is one that contemporary physics has reasons to take seriously rather than dismiss. If physical information is genuinely conserved across all physical processes, including the evaporation of black holes, then contemporary physics has revealed something about the structure of reality that bears in striking ways on the broader question of what happens to a conscious being at death. The Christian theological tradition has articulated frameworks for thinking about death and immortality across 2,000 years of careful theological reflection. The framework was developed initially through the New Testament writings, with the resurrection of Christ being treated as the foundation for the broader Christian understanding of what happens to human beings at death. The early Christian framework holds that physical death is not the end of a conscious being, but is a transition through which the deeper self passes into the broader life of God. The framework was articulated by Paul in his first letter to the Corinthians in the 1st century, where he argued that the physical body that is sown in death is raised in a transformed spiritual body that participates in the resurrection of Christ. Paul's framework in the 15th chapter of 1 Corinthians develops the position with extensive philosophical care, arguing through a sustained comparison of the natural body and the spiritual body that what is raised in resurrection is not simply the natural body restored to its previous condition, but is the natural body transformed into a mode of existence that is compatible with the divine life. The framework was elaborated across centuries of Christian theological reflection. Augustine developed detailed treatments of the relationship between the soul and the body in the City of God across the early 5th century, arguing through extensive philosophical analysis that the soul is the principle that gives unity to the embodied person, and that persists beyond biological death through the continuing creative act of God. Augustine's framework in the City of God addressed the question of the resurrection in particular detail, arguing that the resurrection body is the same body that died, restored to participation in the divine life, rather than replaced by a different body. Aquinas provided systematic philosophical articulation of the framework in the Summa Theologiae across the 13th century, working through the implications of Aristotelian philosophy for the Christian understanding of the relationship between soul and body. The Thomistic framework treats the soul as the substantial form of the body, the principle that organizes the matter of the body into the unified being of a conscious person, with the soul persisting beyond biological death, not as a separate substance that exists independently of the body, but as the deeper organizing principle of the person that participates in the divine being. The framework was developed through extensive philosophical reflection on the relationship between matter and form, with the Aristotelian framework that Aquinas adopted, treating the soul not as a Cartesian substance somehow attached to the body, but as the deeper actualizing principle of the embodied person. The framework has been one of the central frameworks within which Christian thought has addressed the question of death across 2 millennia, with subsequent theologians continuing to develop it through engagement with contemporary philosophical and scientific developments. The Eastern Christian tradition has developed parallel frameworks through its theology of theosis, divinization, articulated most fully by Maximus the Confessor in the 7th century, and elaborated across centuries of orthodox theological reflection, with the framework treating the destiny of the conscious being as participation in the divine life, rather than merely continued existence in some altered form. The Hindu philosophical tradition has articulated its own substantial framework for thinking about death and the persistence of consciousness across more than 3,000 years of careful reflection. The framework operates within the broader Hindu commitment to the existence of an eternal self, Atman, that is identical at its deepest level with the deeper reality of Brahman. The framework holds that physical death is not the end of this deeper self, but is a transition through which the Atman passes from one embodied form to another, with the specific tradition of samsara articulating the cycle of birth and death that the Atman undergoes across multiple lifetimes. The framework was developed in the Upanishads, composed across centuries, beginning around the 8th century before the Common Era. The Katha Upanishad, composed around the 5th century before the Common Era, articulates the framework with particular philosophical depth through the dialogue between the young Brahmin Nachiketa and Yama, the Lord of Death, in which Yama instructs Nachiketa about the nature of the deeper self and its relationship to the cycle of death and rebirth. The Bhagavad Gita articulates the framework with particular directness in its 2nd chapter, with Krishna teaching Arjuna that the self is never born and never dies, that it cannot be cut by weapons or burned by fire, that it passes from one body to another as a person changes worn-out clothes for new ones. The framework was articulated with particular philosophical precision through the Advaita Vedanta tradition developed by Shankara in the 8th century. Shankara argued through his commentaries on the Brahma Sutras and the Upanishads that the deeper self that persists across multiple lifetimes is ultimately identical with Brahman, with the apparent multiplicity of cells being Maya, appearance. The framework treats the apparent transmigration of the self across lifetimes as a feature of the surface manifestation of reality rather than as a feature of the deeper reality, with the deeper reality being the timeless, non-dual awareness in which all apparent distinctions dissolve. The framework was also articulated through the Vishishtadvaita tradition developed by Ramanuja in the 11th century, which treats the individual selves as real, but as ultimately participating in the broader being of God, and the Dvaita tradition developed by Madhva in the 13th century, which treats the individual selves as genuinely distinct from God, while being ultimately dependent on God for their existence. The frameworks share the recognition that biological death is not the end of what we are at our deepest level, and that careful philosophical and contemplative inquiry reveals dimensions of conscious being that ordinary perception cannot directly access. The frameworks differ in their specific accounts of how the relationship between the individual self and the broader reality should be understood. The traditions developed sophisticated philosophical resources for distinguishing between conventional and ultimate levels of reality, with the conventional level corresponding to what ordinary perception encounters, and the ultimate level corresponding to what careful philosophical and contemplative inquiry reveals. The Buddhist tradition has articulated its own substantial framework for thinking about death across more than 2,500 years. The framework operates within the broader Buddhist commitment to the absence of a permanent self that persists unchanged across temporal succession. What persists at death on the Buddhist framework, is not a soul in the Christian sense or an Atman in the Hindu sense, but a continuity of consciousness that the tradition characterizes through specific philosophical vocabulary. The framework operates through the doctrine of the five aggregates, the skandhas, which constitute what we ordinarily take to be a conscious being, with the framework treating these aggregates as continuing to influence subsequent moments of consciousness across the transition through death, without there being any permanent self that carries this continuity. The Mahayana Buddhist tradition developed elaborate frameworks for understanding what happens to consciousness in the period between biological death and subsequent rebirth, with the Tibetan Buddhist tradition developing the most detailed of these frameworks through the Bardo Thodol, the Tibetan Book of the Dead. The text was composed by the 8th century Buddhist master Padmasambhava, who had brought Vajrayana Buddhism from India to Tibet, and was preserved through the Terma tradition until it was rediscovered by the 14th century treasure finder Karma Lingpa. The text articulates a detailed account of the period between biological death and subsequent rebirth, with specific instructions for how the dying person and those who accompany them can navigate this period. The framework describes 6 bardo states, intermediate states, through which consciousness passes between biological death and rebirth. The first 3 bardos correspond to ordinary embodied life, the dream state, and meditative absorption. The final 3 correspond specifically to the period of dying, the period immediately after death, and the period of seeking rebirth. The framework treats the period of dying as one in which the deeper structure of consciousness becomes accessible in ways that ordinary embodied experience does not permit, with the dying person experiencing the clear light of awareness in a form that ordinarily is obscured by the patterns of conventional perception. The framework provides specific practices for recognizing this clear light at the moment of death, with the recognition being treated as the opportunity for liberation from the cycle of rebirth altogether. For those who do not recognize the clear light at the moment of death, the framework describes the experiences that consciousness undergoes across the following days as it passes through various states before being carried by its accumulated patterns toward a new embodiment. The framework has been one of the most influential treatments of death in any contemplative tradition, and has shaped the development of Buddhist thought across Asia for more than 12 centuries. The Pure Land Buddhist tradition, developed in China and Japan through the work of teachers including Tangent Luan in the 6th century, Shan Tao in the 7th century, and Honen and Shinran in the 12th and 13th centuries in Japan, articulates a different framework in which the dying person can be carried by the compassion of Amitabha Buddha into a realm in which the conditions for enlightenment are present in ways that ordinary worldly existence does not provide. The Tibetan tradition has continued to develop these frameworks across centuries, with contemporary teachers, including the late Sogyal Rinpoche, articulating the framework for contemporary Western audiences through works including the Tibetan Book of Living and Dying. The Taoist tradition has articulated its own framework for understanding death through the broader cosmological framework of Chinese philosophy. The framework operates within the broader Taoist commitment to Tao as the underlying source from which all phenomena emerge and to which they return. Physical death, on the Taoist framework, is not the destruction of what we are, but is a transformation through which the specific configuration of our embodied existence dissolves back into the broader patterns of Tao from which it emerged. The framework was articulated most fully through the writings of Zhuangzi in the 4th century before the Common Era, particularly in the famous passage in which Zhuangzi describes his own response to the death of his wife. The passage appears in the 18th chapter of the Zhuangzi and recounts an encounter between Zhuangzi and his friend Huixi, who finds Zhuangzi sitting on the ground beating a drum and singing shortly after his wife's death. Huixi expresses shock at Zhuangzi's apparent lack of grief. Zhuangzi explains that he had initially grieved as anyone would, but that on reflection he had come to recognize his wife's death as a return to the broader patterns of Tao from which all specific phenomena emerge. The framework does not treat death as the end of what she was at her deepest level. It treats death as a transformation through which her specific embodied form returns to the broader cosmic process. The framework treats grief as appropriate to the conventional level at which we encounter the death of someone we love, while also articulating a deeper level at which the transformation through death can be understood as one phase in the broader process of Tao, rather than as the absolute end of what the person was. The framework has been one of the influential treatments of death in the Chinese philosophical tradition and has shaped the development of Chinese thought across millennia. The Confucian tradition has articulated different frameworks that focus more on the continuity of family relationships and ancestral remembrance, with the framework treating the continuing presence of the dead through the remembrance of the living as a feature of what death means, rather than as a separate phenomenon. The Confucian framework was developed through the writings of Confucius himself in the 5th century before the Common Era, and elaborated by subsequent Confucian philosophers including Mencius and Junzi, with a broader Confucian tradition treating the rituals of ancestor remembrance as central to the maintenance of the social fabric and to the proper relationship between the living and the dead. The frameworks differ in their specific emphases. They share the recognition that the simple framework of death as the absolute end of what we are is not adequate to the deeper structure of human existence. The contemporary physics of black hole information has continued to develop across the 5 decades since Hawking's original 1974 paper, and the broader framework has shifted in ways that have substantial implications for the question of what happens to information across physical processes. Hawking's original analysis had suggested that information is permanently destroyed when a black hole evaporates. The implication conflicted with one of the foundational principles of quantum mechanics, the principle that physical information must be conserved across all physical processes. The conflict, which has come to be known as the black hole information paradox, has been one of the central debates in theoretical physics across the past 5 decades. The American physicist Leonard Susskind, working at Stanford, and the Dutch physicist Gerard 't Hooft, working at Utrecht, developed across the 1990s an alternative framework called the holographic principle, which proposes that all the information contained in a region of space can be encoded on the 2-dimensional boundary of that region. The framework was motivated initially by the recognition that the entropy of a black hole is proportional to the surface area of its event horizon rather than to its volume, which suggested that the fundamental information content of any region might be a 2-dimensional quantity rather than a 3-dimensional one. The framework has substantial implications for the broader question of what information is and how it relates to the physical structures that we ordinarily take to be 3-dimensional. The framework that has emerged across this debate is that information is most likely conserved even across the evaporation of black holes, with a specific mechanism by which this conservation operates being one of the open questions of contemporary physics. The Argentinian physicist Juan Maldacena, working at the Institute for Advanced Study in Princeton, developed in 1997 a framework called the ADS-CFT correspondence that has provided one of the most influential approaches to understanding how information is conserved across black hole processes. The framework, articulated initially in a paper titled The Large N Limit of Superconformal Field Theories and Supergravity, demonstrated a mathematical equivalence between certain gravitational theories in higher dimensional spacetimes and quantum field theories on the boundaries of those spacetimes. The framework implies that the information about what happens in the gravitational theory, including the information about what falls into black holes, is encoded in the quantum field theory on the boundary in ways that preserve the information across all physical processes. The Maldacena paper has become one of the most cited papers in the history of theoretical physics, with citation counts in the tens of thousands across the subsequent decades. The framework has been developed across decades of subsequent work by physicists including Edward Witten at the Institute for Advanced Study, Stephen Gubser at Princeton, and many others, and has become one of the most studied frameworks in contemporary theoretical physics. The framework remains contested in its specific interpretation, but the broader implication that information is conserved even across the most extreme physical processes has become widely accepted within mainstream physics. Hawking himself eventually conceded the point in his 2004 paper at the Dublin Conference on General Relativity and Gravitation, where he acknowledged that information is most likely conserved across black hole evaporation, contrary to his original 1974 conclusion. The implication, when extended to the broader question of what happens to the information that constitutes a conscious being at biological death, suggests that the information is not destroyed by death, even though the specific embodied form in which it was instantiated is destroyed. The information persists in some form within the broader structure of physical reality, even when the specific configuration in which it was embedded is no longer present. What contemporary physics suggests through these frameworks is something more striking than the popular discussions of life after death have often articulated. The framework does not establish that conscious beings persist after biological death in the form of disembodied spirits that can communicate with the living through mediums, or that can intervene in the affairs of the world. The framework does not establish any specific religious doctrine about what happens after death. What the framework establishes is something more modest and more philosophically interesting. The information that constitutes a conscious being at the deepest level appears to be conserved across all physical processes, including the biological process of death. What this means for the broader question of what happens to a conscious being at death is something that contemporary physics has not definitively settled. The information being conserved is compatible with multiple specific accounts of what happens to the conscious being. The information could be conserved in ways that involve the continuation of conscious experience in some form. The information could be conserved in ways that involve only the persistence of patterns that no longer constitute conscious experience. The interpretation of what conservation means for conscious experience is not something that physics by itself can settle. What physics can establish is that the information is conserved. What conservation means for the broader question of what we are at our deepest level is a question that requires careful philosophical and contemplative engagement beyond what physics alone can provide. The Christian framework of the immortality of the soul, the Hindu framework of the eternal Atman, the Buddhist framework of the continuity of consciousness across the Bardo states, and the Taoist framework of return to the broader patterns of Tao, all articulate frameworks within which physical death is not the end of what we are at our deepest level. The frameworks differ in their specific theological commitments. They share the recognition that the simple framework of death as the absolute destruction of what we are is not adequate to the deeper structure of human existence. The contemporary physics of information conservation, including the work on the black hole information paradox, the holographic principle developed by Susskind and Hooft, and the ADS-CFT correspondence developed by Maldacena, has revealed structural features of physical reality that are at minimum compatible with these traditional frameworks, even if the physics by itself does not establish any specific framework. The compatibility is not the kind of confirmation that would establish any particular traditional framework as scientifically validated. The compatibility is the more modest recognition that contemporary physics has not closed the questions that the traditional frameworks were addressing, and that careful engagement with the traditional frameworks remains a legitimate intellectual enterprise rather than a retreat from the implications of contemporary science. Whether the convergence between contemporary physics and the traditional frameworks is meaningful, or whether the convergence is structural coincidence between very different inquiries operating in very different contexts, is a question that careful inquirers continue to engage. The convergence is striking. The convergence is not proof. What follows from the convergence depends on what one brings to its interpretation. The popular discussions of physics and life after death have often distorted what the physics actually shows. The popular framework that holds that quantum mechanics or information conservation supports specific claims about what happens after death, including claims about communication with deceased persons through mediums, claims about specific religious doctrines being scientifically vindicated, or claims about the immortality of consciousness in any specific technical sense, draws specific implications from contemporary physics that the physics itself does not support. The physics establishes that information is conserved across physical processes. The physics does not establish that specific frameworks for understanding what happens to conscious beings after death are scientifically validated. The medium industry in particular has been extensively criticized by careful inquirers across the past century, with the American magician and skeptical investigator James Randi having documented across decades the specific techniques that mediums use to produce the appearance of communication with the dead. These techniques include cold reading, the practice of generating specific apparent information about a deceased person by reading subtle cues from the living family members, and hot reading, the practice of researching the family members in advance and then presenting researched information as though it had been received through paranormal means. The techniques have been documented through extensive investigation and have been demonstrated to produce the same kinds of apparent results that mediums claim to produce through paranormal connection to the dead. The framework that treats medium communications as evidence for the persistence of consciousness after death does not survive careful examination. Similarly, the popular framework articulated through various works by Deepak Chopra and other popularizers that holds that quantum mechanics scientifically validates specific spiritual claims about death does not survive careful examination. The conditions under which quantum effects produce observable consequences are very specific and do not include the kinds of macroscopic phenomena that the popular framework describes. The popular framework that conflates these very different positions does not survive careful examination. The framework has been criticized by serious physicists and philosophers across the past several decades, with critics including the physicist Sean Carroll articulating the various ways in which the popular framework distorts what the physics actually establishes. The careful position, which this documentary maintains throughout, is that contemporary physics has revealed structural features of physical reality that are compatible with traditional frameworks for understanding death without establishing any specific traditional framework as scientifically validated, and without establishing any of the various popular extensions that have been built around the convergence between physics and traditional frameworks. The compatibility is genuine. The popular extensions have often gone substantially beyond what the physics supports. What contemporary physics has established across the 5 decades since Hawking first articulated the black hole information paradox is that information conservation appears to be one of the most fundamental principles of physical reality, holding even across the most extreme physical processes, including the evaporation of black holes. What this principle means for the broader question of what happens to the information that constitutes a conscious being at biological death is one of the open questions of contemporary thought. The traditional frameworks for understanding death have articulated frameworks that are at minimum compatible with what contemporary physics has now established. The Christian framework, the Hindu framework, the Buddhist framework, the Taoist framework, and the various other traditional frameworks for understanding death each articulate the position that biological death is not the absolute end of what we are at our deepest level. The contemporary physics of information conservation does not contradict these frameworks. The contemporary physics does not by itself establish these frameworks either. What contemporary physics provides is a framework within which the traditional frameworks can be engaged as serious contributions to the broader inquiry into what death means for what we are, rather than being dismissed as the products of frameworks that contemporary science has superseded. The traditional frameworks were developed across millennia by inquirers using the methods of contemplative practice and careful philosophical reflection. The contemporary physics has been developed across the past century by inquirers using the methods of mathematical analysis and laboratory measurement. The two inquiries arrive at frameworks that bear striking structural resemblance to each other. Whether the resemblance reflects something genuine about the structure of reality, or whether it reflects the specific preferences that inquirers have brought to their interpretations, is the question whose answer remains yours to develop rather than mine to provide. The next stage of the documentary will examine a question that bears directly on what we have been examining. If information is conserved across physical processes, and if the traditional frameworks for understanding death articulate compatible positions about what we are at our deepest level, what does this mean for the broader question of what consciousness is? Is consciousness simply an emergent property of complex physical processes, as the materialist framework has assumed? Or is consciousness more fundamental to the structure of reality than the materialist framework had allowed? The contemporary physics of consciousness, including the work of Penrose and Hameroff on the orchestrated objective reduction theory, the broader frameworks of contemporary philosophy of mind, and the philosophical tradition that has addressed the question across millennia, all bear on this question. The convergences continue in this domain, as in the others. The convergences continue to fall short of proof. What the convergences mean for the broader question of how to understand the situation in which we find ourselves is the question whose answer remains yours to develop rather than mine to provide. In 1994, at the first Tucson Conference on Consciousness, organised by Stuart Hameroff at the University of Arizona, a young Australian philosopher named David Chalmers delivered a lecture that would transform the contemporary conversation about consciousness. Chalmers, who was then completing his doctoral work at Indiana University under the supervision of Douglas Hofstadter, presented what he called the hard problem of consciousness. The conference itself, which became known as Toward a Science of Consciousness and has continued to be held biannually across the subsequent 3 decades, was the first major academic gathering to treat consciousness as a legitimate subject for interdisciplinary scientific and philosophical investigation. The participants included philosophers, neuroscientists, physicists, and contemplatives from multiple traditions. The framework that Chalmers articulated at this conference distinguished between what he called the easy problems of consciousness and the hard problem. The easy problems, despite their name, are extraordinarily difficult. They include the questions of how the brain integrates information from different sources, how it produces the behavioral responses that organisms exhibit, how it generates the verbal reports that conscious beings produce about their own mental states, how attention is allocated and shifted, how memories are stored and retrieved, how decisions are made. The easy problems are not easy in any absolute sense. They are easy only in the specific sense that we have a clear framework within which they can in principle be addressed through contemporary neuroscience and cognitive science. We may not currently have the specific scientific resources to solve any particular easy problem, but we have a clear conception of what a solution would look like and what kinds of evidence would establish it. The hard problem, on Chalmers' framework, is different in kind. It is the problem of why there is something it is like to be a conscious being at all. Why is the processing of information accompanied by subjective experience? Why is there a felt quality to the perception of red, the taste of wine, the experience of pain? The hard problem, as Chalmers articulated it, cannot be addressed by the methods that work for the easy problems. The methods of contemporary neuroscience can describe the physical processes that accompany conscious experience. They cannot explain why these physical processes are accompanied by subjective experience at all. The framework that Chalmers developed across his subsequent work, including his 1996 book, The Conscious Mind, has shaped the contemporary philosophy of mind across the past 3 decades. The framework draws on earlier articulations of similar concerns, including the American philosopher Thomas Nagel's 1974 paper, What Is It Like to Be a Bat?, which had already articulated some of the central insights that Chalmers would develop, and the Australian philosopher Frank Jackson's 1982 paper Epiphenomenal Qualia, which had presented the famous thought experiment about Mary, the colour scientist that bears on similar questions. The framework has not been universally accepted. Various philosophers and scientists have argued that the hard problem is not a genuine problem, or that it can be addressed within frameworks that the standard materialist position permits. Daniel Dennett has been one of the most prominent critics of the framework, arguing across multiple books, including Consciousness Explained in 1991 and From Bacteria to Bach, and back in 2017, that the hard problem dissolves when consciousness is properly understood. But the framework has established the question in a form that contemporary thought has had to engage seriously rather than dismiss. The question that Chalmers articulated is not a new question. The great philosophical and contemplative traditions of the world have addressed the question of what consciousness is for more than 3,000 years through frameworks that have arrived at positions which bear striking structural resemblance to what contemporary philosophy of mind has begun to articulate. The Hindu philosophical tradition has developed perhaps the most sustained engagement with the nature of consciousness in any tradition. The framework operates through the doctrine of Sit, consciousness, which the Hindu tradition treats not as a feature added to material processes, but as the deeper reality of which material processes are expressions. The framework is articulated through the triad of Satchitananda, being consciousness bliss, which the tradition treats as the three aspects of the deeper reality of Brahman. The Upanishads, composed across centuries beginning around the 8th century before the Common Era, articulate the framework with particular philosophical depth. The Mandukya Upanishad, one of the shortest but philosophically most important of the Upanishads, articulates a fourfold analysis of consciousness that distinguishes between the waking state, Vaishvanara, in which consciousness experiences the gross material world through the body, the dream state, Taijasa, in which consciousness experiences subtle mental phenomena without external sensory input, the deep sleep state, Prajna, in which consciousness exists as undifferentiated awareness without specific objects, and what the tradition calls Turiya, the fourth state, which is held to be the deeper reality of which the other three are surface manifestations. Turiya is not a fourth state alongside the other three. Turiya is the underlying ground of all three states, the pure awareness that is present in waking, in dreaming, and in deep sleep, but that is not exhausted by any of these specific states. The framework treats consciousness as fundamental rather than emergent, with the apparent material world being understood as the expression of consciousness rather than as the substrate from which consciousness somehow emerges. The framework was elaborated across centuries through the work of Hindu philosophers, including Gaudapada in the 7th century, whose Mandukya Karika provided the philosophical foundation for the subsequent Advaita Vedanta tradition, through extensive analysis of the fourfold framework of consciousness articulated in the Mandukya Upanishad. Shankara, in the 8th century, developed the framework with particular philosophical precision, arguing through his commentaries on the Upanishads, the Brahma Sutras, and the Bhagavad Gita that consciousness, at its deepest level, is identical with the deeper reality of Brahman, with the apparent multiplicity of individual conscious beings, being Maya, appearance. The framework was developed in different directions by subsequent Vedantic philosophers, including Ramanuja in the 11th century, whose Vishishtadvaita framework treats individual consciousnesses as real modes of the deeper divine consciousness rather than as appearances, and Madhva in the 13th century, whose Dvaita framework treats individual consciousnesses as genuinely distinct while being dependent on the broader divine consciousness. The framework has been one of the most influential treatments of consciousness in any philosophical tradition. The Buddhist tradition has articulated its own substantial framework for thinking about consciousness across more than 2,500 years. The framework operates within the broader Buddhist commitment to the absence of a permanent self, which distinguishes it from the Hindu framework even as the two traditions arrive at structurally similar positions about the fundamentality of consciousness. The Yogacara school of Buddhism, developing in India in the 4th century through the work of the brothers Asanga and Vasubandhu, articulated a framework in which all apparent phenomena are manifestations within consciousness, with the framework being called Citamatra, mind only, or Vinaptimatra, representation only. Asanga's major works, including the Mahayana Samgraha and the Yogacara Bhumi, developed the broader Yogacara framework across multiple volumes of detailed philosophical analysis. The framework articulates an analysis of consciousness through what the tradition calls the 8 consciousnesses, which include the 5 sensory consciousnesses, the mental consciousness that integrates the sensory inputs, the manas consciousness that generates the apparent sense of self, and the alaya vijnana, the storehouse consciousness, which is held to be the deeper substrate from which the other consciousnesses arise. The framework treats the alaya vijnana as the foundational level of consciousness that carries the karmic seeds from which subsequent experience emerges, with the framework providing a detailed analysis of how the apparent stream of conscious experience is generated from this deeper substrate. Vasubandhu's Vimsatika and Trimsika, composed in the 4th century, developed the framework through sustained philosophical analysis. The Vimsatika consists of 20 verses, with extensive commentary that argues against the realist position that the apparent objects of perception exist independently of consciousness. The argument proceeds through a sustained engagement with various counter-arguments that the realist position might offer, demonstrating through philosophical analysis that what we ordinarily take to be external material objects existing independently of consciousness are in fact manifestations within consciousness. The Trimsika consists of 30 verses that develop the positive Yogacara framework through analysis of the 8 consciousnesses and the structure of conscious experience. The framework was elaborated across centuries by Buddhist philosophers including Dignaga in the 6th century, whose Pramanasamukaya developed the broader epistemological framework of Buddhist logic within which the Yogacara position was articulated, and Dharmakirti in the 7th century, whose Pramanavartika continued the development of Buddhist epistemology in the Yogacara tradition. The framework was transmitted through East Asia, where it became foundational to Chan Buddhism in China, developed initially by the patriarchs Bodhidharma, Huineng, and the broader Chan tradition, and Zen Buddhism in Japan, with the framework being central to the philosophical articulations of Zen masters across centuries, including Dogen in the 13th century, whose Shobogenzo developed sophisticated treatments of consciousness through specific philosophical formulations, including the doctrine of being time, Uji. The framework has been one of the central insights of Buddhist thought and has been understood across the tradition as articulating something genuine about the structure of conscious experience that ordinary perception conceals. The framework anticipates in remarkable ways what contemporary philosophy of mind has begun to articulate through frameworks that treat consciousness as fundamental rather than emergent. The Christian theological tradition has articulated its own framework for understanding the relationship between consciousness and material processes across 2,000 years of careful theological reflection. The framework was developed initially through the engagement of early Christian thinkers with the Greek philosophical tradition, particularly with the work of Plato and Aristotle. Augustine, in the 5th century, working primarily within the Platonic framework, treated the soul as the principle that animates the body and that participates in the deeper reality of divine being. His articulation in On the Trinity developed a sophisticated analysis of the structure of consciousness through the analogy of the divine Trinity, with consciousness exhibiting a tripartite structure of memory, understanding, and will that mirrors the structure of divine reality. The framework was developed in different directions by Aquinas in the 13th century through his engagement with Aristotelian philosophy. The Thomistic framework treats the soul as the substantial form of the body, the principle that organizes the matter of the body into the unified being of a conscious person. The framework does not treat the soul as a separate substance that exists independently of the body, as the Cartesian framework would later articulate in the 17th century through Descartes' famous distinction between res cogitans and res extensa. The Thomistic framework treats the soul as the deeper actualizing principle of the embodied person, with the unity of consciousness emerging from the unity of the form rather than from any additional substance. The framework was developed in opposition to the broader Platonic dualism that earlier Christian thought had absorbed, with Aquinas arguing that the proper understanding of consciousness requires treating the soul and body as related through the metaphysical structure of substantial form, rather than as separate substances joined together. The framework has been one of the most philosophically sophisticated treatments of the relationship between consciousness and material processes in any tradition. The framework was developed across centuries by Christian theologians and philosophers, with the medieval scholastic tradition elaborating the framework through extensive philosophical reflection by figures including Bonaventure, Albertus Magnus, and Duns Scotus. The framework has continued to be developed in the modern period through the work of Catholic philosophers, including Edith Stein in the early 20th century, whose engagement with Husserlian phenomenology produced a sophisticated framework for understanding the relationship between consciousness and embodiment, and Karol Wojtyla, the future Pope John Paul II, whose 1000 969 book The Acting Person articulated a contemporary framework for understanding the unity of consciousness and embodied action. The most sophisticated contemporary scientific framework that takes the relationship between consciousness and quantum mechanics seriously is the orchestrated objective reduction theory, developed by the British mathematical physicist Roger Penrose and the American anesthesiologist Stuart Hameroff across the past 4 decades. Penrose, working at Oxford and having shared the Nobel Prize in Physics in 2020 for his work on general relativity and black holes, had argued in his 1989 book, The Emperor's New Mind, that consciousness involves features that no classical computational framework can adequately accommodate. Penrose was uniquely positioned to make this argument. He had been one of the central figures in the development of general relativity and the mathematical understanding of black holes across the 1960s and 1970s, work that established him as one of the most accomplished mathematical physicists of his generation. His engagement with the foundations of consciousness was not the work of a popularizer, but of a physicist whose technical credentials were beyond question. The argument that Penrose developed drew on Gödel's incompleteness theorems, which had been proved by the Austrian logician Kurt Gödel in 1931 inches, his paper on formally undecidable propositions of Principia Mathematica and related systems. Gödel's theorems demonstrated that any sufficiently powerful formal mathematical system must contain truths that cannot be derived from the axioms of the system, and that the consistency of such a system cannot be proved from within the system itself. Penrose argued that human mathematical understanding routinely engages with truths of this kind, recognizing them as true even though no algorithmic derivation from any specific set of axioms can establish them. Mathematicians who recognize the truth of Gödel's sentences on Penrose's argument are doing something that no classical algorithm can do, and therefore consciousness must involve processes that operate beyond what classical computation can provide. The argument, developed across the Emperor's New Mind and elaborated in his 1994 book Shadows of the Mind, has been controversial. Critics have argued that the argument either misinterprets Gödel's theorems or fails to establish that consciousness must involve non-algorithmic processes. The argument has continued to be defended by Penrose and developed in response to criticism. Whatever the merits of the specific Gödelian argument, the broader framework that Penrose was articulating, in which consciousness involves features that go beyond what classical computation can provide, and that may require quantum processes operating at the fundamental level of physical reality, has been one of the most influential frameworks in the contemporary engagement with the question of consciousness. The collaboration with Hameroff added a specific biological substrate to the framework. Hameroff, an anesthesiologist who had spent his career at the University of Arizona in Tucson, studying the mechanisms by which anesthetic drugs produce unconsciousness, had observed across his clinical practice that the anesthetic drugs that produce unconsciousness bind specifically to microtubules within neurons, rather than to the neural membranes that classical neuroscience had assumed were the primary site of anesthetic action. Microtubules are protein structures that constitute the cytoskeleton of all cells, with neurons containing particularly elaborate microtubule structures arranged in specific patterns within the dendrites and the cell bodies. The microtubules are constructed from tubulin proteins that can exist in multiple conformational states, with the specific patterns of these states across the microtubule network providing potential substrates for information processing that operates differently from the classical electrochemical signaling that conventional neuroscience had, identified as the basis of brain function. Hameroff proposed that microtubules might be the specific location where the quantum processes that Penrose had identified as necessary for consciousness actually take place. The collaboration between Penrose and Hameroff, which began in the early 1990s after Hameroff read The Emperor's New Mind and recognized that Penrose was looking for exactly the kind of biological substrate that microtubules might provide, has continued across more than 3 decades. The collaboration produced the orchestrated objective reduction theory, with the framework being articulated through multiple papers across the 1990s and 2000s and continuing to be developed in response to empirical and theoretical challenges. The framework holds that the moment-to-moment generation of conscious experience involves the orchestrated collapse of quantum states in microtubules through gravitational mechanisms operating at the fundamental level of physical reality. The framework treats the discrete moments of conscious experience as corresponding to specific quantum reduction events, with the orchestration of these events across the microtubule networks of the brain producing the unified subjective character of conscious experience. The framework remains controversial within mainstream neuroscience. Critics, including the Swedish-American physicist Max Planck, working at MIT, published in 2000 an influential paper arguing that the kind of quantum coherence that the framework requires cannot be maintained in warm biological systems because of decoherence. The rapid loss of quantum coherence that occurs when quantum systems interact with their environment. The framework has continued to develop in response to these criticisms. The empirical support for the framework has continued to develop across the past decade. The work of the Indian physicist Anirban Bandyopadhyay at the National Institute for Material Science in Japan has documented quantum coherent vibrations in microtubules under physiologically relevant conditions across multiple peer-reviewed studies published since 2014. The findings demonstrate that microtubules exhibit the kinds of quantum coherent behaviors that the Penrose-Hameroff framework would predict, with specific resonance frequencies in the gigahertz and megahertz ranges that correspond to the timescales of conscious processing. The 2024 work of Mike Wiest at Wellesley College examined the effects of microtubule stabilizing anesthetics on consciousness in animal models, finding that anesthetics that bind specifically to microtubules produce effects on consciousness that are consistent with the predictions of the Penrose-Hameroff framework. The framework continues to be developed and to attract serious engagement from physicists, neuroscientists, and philosophers, even as it remains controversial within mainstream neuroscience. What the framework does, regardless of whether it turns out to be correct in its specific claims, is to make available a contemporary scientific framework within which the question of the relationship between consciousness and the fundamental structure of reality can be addressed without retreating to either pure materialism or pure spiritualism. The contemporary philosophy of mind has developed several other frameworks for addressing the hard problem that bear on the question of what consciousness is. The integrated information theory developed by the Italian-American neuroscientist Giulio Tononi, working at the University of Wisconsin, proposes that consciousness corresponds to the integrated information of a physical system. The framework, developed across the past 2 decades and articulated most fully in Tononi's 2012 book Phi and in subsequent papers, including his work with Christoph Koch at the Allen Institute for Brain Science, treats consciousness as a fundamental feature of any physical system that exhibits the specific patterns of integrated information that the framework identifies. The framework quantifies consciousness through a measure called phi, with phi being a specific mathematical quantity that captures the degree to which a system integrates information beyond what its parts could process independently. The framework implies that consciousness is not unique to biological brains, but is exhibited to varying degrees by all physical systems that have the relevant integrated informational structure, with simple systems having minimal consciousness and complex systems having more substantial consciousness. The framework has been controversial within philosophy of mind. Critics have argued that the framework either overcounts consciousness, attributing consciousness to systems that do not have it, or undercounts consciousness, missing features of conscious experience that the framework does not capture. The framework has continued to be developed and to attract serious engagement, with the broader research program continuing to refine the specific measures of integrated information and to test the framework against empirical findings about which physical systems exhibit consciousness. The framework of panpsychism, the position that consciousness is a fundamental feature of physical reality rather than an emergent property of complex physical systems, has been developed across the past 2 decades by philosophers including the British philosopher Galen Strawson, who has argued for the position in essays published since 2006 and collected in his 2008 book Real Materialism, and the British philosopher Philip Goff, whose 2017 book Consciousness and Fundamental Reality and 2019 book Galileo's Error articulated the framework for broader audiences. Strawson's argument, developed across multiple papers, holds that the standard materialist position cannot adequately explain how consciousness emerges from non-conscious matter, and that the only coherent materialist position must therefore treat consciousness as one of the fundamental features of matter rather than as an emergent property. The argument has been influential within philosophy of mind, even among philosophers who do not accept the broader panpsychist conclusion. Goff has developed the framework with particular philosophical depth across his subsequent work, arguing that panpsychism provides a more parsimonious explanation of consciousness than the alternatives, and that the framework should be taken seriously as a contribution to the broader philosophy of mind. The panpsychist framework treats consciousness as one of the fundamental features of physical reality, alongside features like mass, charge, and spin, with complex consciousness emerging from the combination of simpler conscious elements through processes that the framework attempts to characterize. The framework has parallels with positions that have been developed in various philosophical traditions across millennia, including the Stoic doctrine of the Logos as pervading all reality, the Neoplatonic doctrine of Nous, the Hindu doctrine of Sit as fundamental, and various positions within Buddhist thought that treat consciousness as more fundamental than the materialist framework had allowed. The framework has been controversial within contemporary philosophy of mind. Critics have raised what is called the combination problem, the question of how simpler conscious elements combine to produce the unified conscious experience that we ordinarily have. The framework has continued to be developed and to attract serious engagement. The framework of analytic idealism, developed across the past decade by the Dutch-Brazilian philosopher Bernardo Kastrup, articulates a contemporary version of the broader idealist tradition. The framework, articulated through several books including The Idea of the World in 2019, treats consciousness as the fundamental level of reality from which the apparent material world emerges as a specific kind of manifestation. The framework draws on Schopenhauer's 19th century idealism, on the Vedantic tradition, and on contemporary work in philosophy of mind to articulate a framework in which what appears as the physical world is the extrinsic appearance of the deeper conscious reality. The framework treats the apparent multiplicity of individual conscious beings as the appearance produced by what Kastrup calls dissociative processes within the broader cosmic consciousness, with the individual conscious beings being understood as specific local manifestations of the deeper reality rather than as independent substances. The framework bears striking structural resemblance to the Vedantic tradition, which it acknowledges as a substantial source. The framework has been controversial within contemporary philosophy of mind. Critics have raised various questions about its specific articulation and about the broader implications of treating consciousness as fundamental. The framework has continued to be developed and to attract serious engagement. The popular discussions of consciousness and quantum mechanics have often distorted what the physics and the philosophy actually show. The popular framework that holds that quantum mechanics scientifically validates specific claims about consciousness, including claims about the power of mind to directly create physical reality, claims about telepathic communication between separated conscious beings, claims about specific spiritual practices being scientifically validated, draws specific implications from contemporary physics and philosophy of mind that the careful work itself does not support. The physics does not establish that consciousness can directly create macroscopic physical events through quantum effects. The philosophy does not establish any specific spiritual framework as scientifically validated. The popular framework that conflates these very different positions does not survive careful examination. The framework articulated through various works by Deepak Chopra and other popularizers, including books like Quantum Healing and various subsequent works, has been extensively criticized by serious physicists and philosophers across the past several decades. with critics including the physicist Sean Carroll, the philosopher Massimo Pigliucci, and the neuroscientist Stephen Novella articulating the various ways in which the popular framework distorts what the careful work establishes. The careful position, which this documentary maintains throughout, is that contemporary physics and philosophy have reopened questions about the nature of consciousness that the materialist framework had treated as closed, without establishing any specific popular framework that has been built around the reopening. The reopening is genuine. The popular extensions have often gone substantially beyond what the careful work supports. The Taoist tradition has articulated its own framework for understanding consciousness through the broader cosmological framework of Chinese philosophy. The framework operates through the concept of Shen, spirit or consciousness, which the tradition treats not as a separate substance added to material processes, but as one of the fundamental aspects of Tao that pervades all phenomena. The framework was developed through the writings of Zhuangzi in the 4th century before the Common Era and elaborated across centuries of Taoist philosophical reflection. The Taoist framework treats consciousness as participating in the broader patterns of Tao, with the apparent separation between individual conscious beings being a feature of how Tao expresses itself through specific local manifestations, rather than a feature of the deeper structure of reality. The framework has been one of the influential treatments of consciousness in the Chinese philosophical tradition and has shaped the development of Chinese thought across millennia. The framework was elaborated through interaction with Buddhist thought after the introduction of Buddhism to China in the early centuries of the Common Era, producing the broader Chan and Zen traditions that combine Taoist and Buddhist insights about the nature of consciousness. The Confucian tradition has articulated different frameworks that focus more on the ethical and social dimensions of consciousness, with the framework treating consciousness as primarily constituted through the relationships and practices that connect human beings to each other and to the broader cosmic order. What contemporary philosophy of mind has established, across the 3 decades since Chalmers first articulated the hard problem, is that the materialist framework that the previous century had taken for granted is not adequate to the documented features of conscious experience. What this means for the deeper question of what consciousness is at its foundations has not been definitively settled. Various frameworks remain available, with the Penrose-Hameroff theory, the integrated information theory, panpsychism, analytic idealism, and various other frameworks continuing to be developed and defended by serious thinkers. Each framework has implications for the broader question of the relationship between consciousness and physical reality. Each framework has structural parallels in the frameworks that the great philosophical and contemplative traditions have developed across millennia. The Hindu framework of Sit as fundamental, the Buddhist framework of Citamatra as the foundational structure of experience, the Christian framework of the soul as the substantial form of the embodied person, the Taoist framework of Shen as participation in Tao, all articulate positions that bear striking structural resemblance to what contemporary philosophy of mind has been articulating, through frameworks that treat consciousness as fundamental rather than emergent. The convergence is striking. The convergence is not proof. What follows from the convergence depends on what one brings to its interpretation. The traditional frameworks were developed across millennia by inquirers using the methods of contemplative practice and careful philosophical reflection. The contemporary frameworks have been developed across the past 3 decades by inquirers using the methods of philosophical analysis, contemporary neuroscience, and engagement with the implications of quantum mechanics for the broader structure of reality. The 2 inquiries arrive at frameworks that bear striking structural resemblance to each other. Whether the resemblance reflects something genuine about the structure of reality, or whether it reflects the specific philosophical preferences that contemporary thinkers have brought to their interpretations of the underlying phenomena, is the question whose answer cannot be settled by either inquiry alone. The careful position is to recognize that the convergence is genuine, that it falls short of proof, and that its interpretation requires the kind of broader philosophical engagement that neither contemporary science nor traditional contemplative inquiry can provide by itself. The next stage of the documentary will examine the broader implications of what we have been examining across the previous stages. If consciousness is more fundamental to the structure of reality than the materialist framework had assumed, if observation participates in shaping what is observed, if time is not what ordinary experience suggests, if the apparent separation between distant beings is not fundamental, if information is conserved across all physical processes including biological death, what does this mean for the broader question of how to understand the situation in which we find ourselves? These questions have been the subject of the great philosophical and contemplative traditions for millennia, and they have been reopened in specific ways by contemporary physics and philosophy. The synthesis that the final stage will attempt is not the settlement of these questions, which lies beyond what any documentary can provide. The synthesis is the articulation of how the convergences we have examined bear on the broader question of what to make of our situation, with the broader question being one whose answer remains yours to develop rather than mine to provide. We have come to the final stage of this documentary. The previous stages have examined what contemporary physics has revealed about the structure of reality and how the frameworks that have emerged from this physics relate to what the great philosophical and contemplative traditions of the world have been articulating across thousands of years. We have examined the question of the observer, of time, of connection, of death, and of consciousness. We have seen across each of these questions that contemporary physics has reopened questions that the merely materialist framework of the previous century had treated as closed. We have seen that the great traditions of the world have articulated frameworks that bear striking structural resemblance to what contemporary physics is now suggesting in its various interpretations. We have seen that the convergence between these contemporary and traditional frameworks is genuine, that it is striking, and that it falls short of proof. The synthesis that this final stage will attempt is not the settlement of any of these questions. The settlement of these questions lies beyond what any documentary can provide. What this final stage can do is articulate how the convergences we have examined bear on the broader question of how to understand the situation in which we find ourselves, and to offer some careful thoughts about what the broader meaning of our investigation might be. The position that the documentary has been articulating across its previous stages can be stated with some precision. Quantum mechanics sits at the edge where science begins to raise questions once reserved for philosophy, theology, and spirituality. As science advanced across the past 4 centuries, the influence of traditional religion weakened in many areas. The phenomena that earlier centuries had attributed to angelic intelligences turned out to follow physical laws that could be calculated. The diversity of living forms turned out to be explicable through processes of variation and selection. The behavior of the planets, the chemistry of matter, the propagation of light, each of these became, across the centuries, the subject of scientific frameworks that did not require the kinds of theological and spiritual frameworks that earlier centuries had assumed were necessary. By the late 19th century, the materialist framework had become so successful that many serious thinkers treated it as the only intellectually defensible position available. And then, beginning in 1900, the framework began to break. The break did not return us to traditional religion in any naive sense. The break revealed that the materialist framework had been making assumptions about the structure of reality that the deeper investigation could not sustain. The break revealed that the questions that earlier centuries had addressed through philosophical and theological frameworks were questions that contemporary physics has had to engage seriously rather than dismiss. The questions of what consciousness is, of how observation relates to physical reality, of what time is at its deepest level, of how the apparent separation between distant beings relates to the deeper structure of reality, of what happens to the information that constitutes a conscious being at death. Each of these questions has been reopened by contemporary physics in ways that the materialist framework of the previous century had not anticipated. What the documentary has not argued, across any of its previous stages, is that contemporary physics confirms any specific religious tradition. The documentary has not argued that ancient traditions anticipated contemporary physics in any precise sense. The documentary has not endorsed the popular claim that quantum mechanics proves the existence of God, the immortality of the soul, the power of mind to create reality, or any of the various other claims that have been made by various popularizers across the past several decades. The careful position, which the documentary has attempted to maintain throughout, is that the convergences between contemporary physics and the great traditions are real and worth examination, but that the convergences fall short of proof, and that any account claiming they amount to proof is overstating what the available evidence supports. What contemporary physics has done is to reopen questions that the materialist framework had treated as closed. The reopening is genuine. What the reopening permits is genuine. What it establishes is more limited than the popular accounts of these matters often suggest. The convergences that we have examined across the previous stages deserve to be considered together rather than separately. Each of the convergences, considered by itself, can be dismissed as a structural coincidence between traditions addressing different questions in similar vocabulary. Considered together, the convergences become more difficult to dismiss. The same pattern appears across multiple independent inquiries. The early quantum physicists, working at the foundations of the materialist science that the previous century had constructed, arrived at positions that the materialist framework alone could not adequately accommodate. Planck found his way to a position that Christian theology had been articulating since the Gospel of John. Einstein found his way to a position that the Spinozist tradition had drawn from Jewish, Christian, and broader philosophical sources. Heisenberg found his way to Plato, whose framework had parallels in Hindu, Buddhist, and Christian thought. Schrödinger found his way to Vedanta. Pauli and Jung found their way to a framework with roots in Neoplatonism, Christian mysticism, Hindu Advaita, and Buddhist Mahayana. Bohr found his way to Taoism. The pattern continued through the subsequent decades of the development of physics. Wheeler arrived at the participatory universe framework that bears striking structural resemblance to what the Hindu Upanishads and the Buddhist Yogacara school had articulated thousands of years earlier. Bohm arrived at the implicate order framework that bears structural resemblance to what the Buddhist Avatamsaka tradition had articulated through the image of Indra's net. Rovelli arrived at the relational framework for time that bears structural resemblance to what the Boethian framework of eternity and the Hindu framework of Brahman beyond time had articulated. Penrose and Hameroff arrived at a framework for consciousness that bears structural resemblance to the Hindu framework of Sit as fundamental and the Buddhist framework of Citta-matra. The pattern is not random. The pattern is consistent across multiple independent inquiries operating in different domains of contemporary physics. The pattern can be examined in more detail through a careful consideration of what each domain has revealed and how the revelations relate to what the great traditions have articulated. The question of the observer, examined in the early stages of the documentary, revealed that quantum mechanics has not been able to formulate a coherent framework within which physical reality exists, with definite properties independent of measurement. The act of measurement participates in determining the outcome of quantum experiments. The standard interpretations of quantum mechanics differ in their specific accounts of how this participation operates, but they share the recognition that the simple picture of an observer externally watching an independently existing reality is not adequate to what the experiments have revealed. The traditional frameworks that articulate structurally parallel positions include the Hindu doctrine of Tattvamasi, articulated in the Chandogya Upanishad more than 2,500 years ago, the Buddhist Yogacara doctrine of Vijñāptimātra, articulated by Vasubandhu in the 4th century, the Christian doctrine of Creatio Continua, developed by Augustine and elaborated by Aquinas across the medieval period, and the Taoist framework of the participation of observer and observed in Tao, articulated by Zhuangzi in the 4th century before the Common Era. The traditional frameworks were developed without any access to the experimental tools of contemporary physics. The traditional frameworks were developed through the methods of sustained contemplative practice and careful philosophical reflection. The convergence between what the traditional frameworks articulated and what contemporary physics has revealed is one of the striking patterns we have examined. The question of time, examined in the 3rd stage of the documentary, revealed that contemporary physics has developed frameworks within which the apparent flow of time, from past through present to future, is not adequate to what relativity and the broader framework of contemporary physics have established. The block universe interpretation of relativity treats past, present, and future as equally real, with the apparent flow being a feature of conscious experience rather than a feature of the underlying physical structure. The framework was articulated by Einstein himself in his letter to the Besso family in March of 1955, 3 weeks before his own death. The contemporary framework of relational time developed by Ravelli treats time as emerging from the relations between physical systems rather than being a fundamental feature of physical reality. The traditional frameworks that articulate structurally parallel positions include the Christian doctrine of eternity, developed most fully by Boethius in his Consolation of Philosophy, composed in his cell in Pavia in 524, while, awaiting execution, the Augustinian framework of the soul as the locus of memory, attention, and expectation developed in the 11th book of the Confessions, around 398. The Hindu framework of Brahman as beyond time elaborated across centuries of Vedantic philosophy, the Buddhist framework of the deeper nature of consciousness as not subject to temporal succession developed across multiple Mahayana traditions, and the Taoist framework of Tao as encompassing all temporal phenomena without itself being temporal. The convergence between contemporary physics and these traditional frameworks is, again, one of the striking patterns we have examined. The question of connection, examined in the 4th stage of the documentary, revealed that contemporary physics has experimentally demonstrated that the apparent separation between distant parts of physical reality is not as fundamental as classical physics had assumed. The non-local correlations between entangled quantum systems exceed what any local theory can produce, with this fact having been established through the experimental work that led to the 2022 Nobel Prize in Physics being awarded to Aspect, Clauser, and Zeilinger. The traditional frameworks that articulate structurally parallel positions include the Buddhist doctrine of pratityasamutpada, articulated by the historical Buddha in the 5th century before the Common Era and elaborated through the Madhyamaka tradition of Nagarjuna, the Huayan Buddhist framework of Indra's net developed by Fazang in the 7th century, the Hindu doctrine of Advaita, developed most fully by Shankara in the 8th century, the Christian doctrine of the mystical body of Christ, developed initially through the letters of Paul in the 1st century, and elaborated across centuries of Christian theological reflection, the Taoist framework of Tao as the underlying unity of all phenomena, articulated by Laozi in the 6th century before the Common Era, and the Sufi framework of Wahdat al-Wujud, developed by Ibn Arabi in the 13th century. The convergence between contemporary physics and these traditional frameworks is one of the most striking patterns we have examined, because the contemporary physics in this domain has produced experimental results that are not merely interpretation dependent, but are robust experimental findings that any framework must accommodate. The question of death, examined in the 5th stage of the documentary, revealed that contemporary physics has come to the conclusion that information is most likely conserved across all physical processes, including the most extreme physical processes such as the evaporation of black holes. The framework, developed across decades of work on the black hole information paradox by Hawking, Susskind, 't Hooft, Maldacena, and others, suggests that the information that constitutes a conscious being is not destroyed by biological death, even though the specific embodied form in which it was instantiated is destroyed. The traditional frameworks that articulate structurally parallel positions include the Christian doctrine of the immortality of the soul, developed across 2,000 years of theological reflection, from Paul through Augustine, and Aquinas, the Hindu doctrine of the eternal Atman, articulated in the Upanishads and elaborated across the Vedantic tradition. The Buddhist framework of the continuity of consciousness across the Bardo states, developed most fully in the Tibetan Buddhist tradition through the Bardo Thodol, and the Taoist framework of return to the broader patterns of Tao, articulated by Zhuangzi. The convergence between contemporary physics and these traditional frameworks is one of the patterns we have examined, Although the contemporary physics in this domain has not by itself established any specific traditional framework, but rather has revealed that the question of what happens to the information constituting a conscious being at death remains genuinely open in ways that the materialist framework had not anticipated. The question of consciousness, examined in the 6th stage of the documentary, revealed that contemporary philosophy of mind has come to recognize that the materialist framework that the previous century had taken for granted is not adequate to the documented features of conscious experience. The hard problem of consciousness articulated by Chalmers in 1994, the Penrose-Hameroff orchestrated objective reduction framework, developed across the past 4 decades, the integrated information theory developed by Tononi, the contemporary panpsychist frameworks developed by Strawson and Goff, and the analytic idealism developed by Kastrup all represent contemporary attempts to address the question of consciousness through frameworks that go beyond what the standard materialist framework had allowed. The traditional frameworks that articulate structurally parallel positions include the Hindu doctrine of Sit as fundamental, with the framework being elaborated through the analysis of the 4 states of consciousness in the Mandukya Upanishad and developed across the Vedantic tradition by Gaudapada, Shankara, Ramanuja, and Madhva. The Buddhist Yogacara framework articulates structurally similar positions through its doctrine of Citamatra, mind only, developed by Asanga and Vasubandhu in the 4th century, and elaborated across centuries of subsequent Buddhist philosophical reflection. The Christian framework of the soul, as the substantial form of the body, articulates a related position through different vocabulary, with the framework being developed most fully by Aquinas in the 13th century. The Taoist framework articulates the participation of consciousness in Tao through the broader cosmological framework of Chinese philosophy. The convergence between contemporary philosophy of mind and these traditional frameworks is one of the most striking patterns we have examined, because the contemporary philosophical work in this domain has been arriving at positions that the materialist framework cannot accommodate, and the traditional frameworks that bear striking structural resemblance to what contemporary philosophy is articulating have been available across millennia. What does the pattern mean? 3 answers are available. The first answer holds that the convergence reflects something genuine about the structure of reality. The ancient traditions had access, through the methods of sustained contemplative practice and careful philosophical reflection, to insights about the structure of reality that contemporary physics is now in the process of rediscovering through different methods. The convergence between the 2 inquiries reflects the underlying reality that both inquiries are addressing. The second answer holds that the convergence is structural coincidence between very different inquiries. The ancient traditions were addressing questions about meaning, value, and human existence through frameworks that happen to use vocabulary structurally similar to what contemporary physics has developed. The use of similar vocabulary does not establish that the inquiries are addressing the same questions or arriving at the same insights. The third answer holds that contemporary physics is being interpreted in ways that import ancient philosophical categories that the physics itself does not require. The physicists who have articulated the contemporary frameworks have brought to their interpretations the specific philosophical preferences that were available in their cultural contexts, and the resulting frameworks reflect these preferences rather than what the physics strictly establishes. Each of these 3 answers has serious defenders within contemporary thought. None of the 3 has been definitively established. The careful position is to recognize that the 3 answers represent 3 possibilities, that the convergence is striking enough to warrant serious engagement with all 3, and that the choice between them depends on broader philosophical and theological commitments that the documentary itself cannot settle. What the documentary can offer is the recognition that the convergences are real, that they are not the products of overheated popular extensions, and that they bear on questions of substantial importance for how to understand the situation in which we find ourselves. The popular extensions of the convergences have often gone substantially beyond what the careful work supports. The popular framework that holds that we create reality with our thoughts articulated through The Secret by Rhonda Byrne and various other popularizations of the manifestation framework, draws from the role of the observer in quantum mechanics implications that the physics itself does not support. The physics shows that the act of measurement participates in determining the outcome of quantum experiments at the quantum scale. The physics does not show that conscious thoughts can directly create macroscopic physical events through quantum effects. The framework that conflates these very different positions does not survive careful examination, and the criticisms that have been articulated against it across the past several decades by serious physicists and philosophers, including Sean Carroll, Massimo Pigliucci, and others, have been substantial. The popular framework that holds that quantum mechanics validates specific spiritual healing practices, articulated through various works by Deepak Chopra, including Quantum Healing and Ageless Body, Timeless Mind, similarly distorts what the careful work establishes. The conditions under which quantum effects produce observable macroscopic phenomena are very specific, and they do not include the kinds of healing claims that the popular framework makes. The medium industry, which claims to provide communication with deceased persons through paranormal connection, has been extensively investigated across the past century, with the American magician and skeptical investigator James Randi having documented across decades the specific techniques of cold reading and hot reading that mediums use to produce the appearance of paranormal communication. The documented techniques produce the same kinds of apparent results that mediums claim to produce through paranormal connection to the dead, and the framework that treats medium communications as evidence for the persistence of consciousness after death does not survive careful examination. The popular framework that treats electronic voice phenomena as evidence for spirit communication, articulated through various television programs and books that emerged in the late 20th century, has been thoroughly criticized by researchers who have demonstrated that the alleged voices in random electronic noise are produced by pareidolia, the human tendency to perceive meaningful patterns in random data, rather than by genuine communications from spirits. The popular framework that treats various synchronicities and meaningful coincidences as signs from deceased persons or from cosmic intelligences similarly draws on pareidolia rather than on genuine phenomena that contemporary research has documented. None of these popular frameworks survives careful examination. The convergences between contemporary physics and the great traditions, when properly understood, do not validate any of these popular extensions. The framework of perennialism, the position that all religions are saying essentially the same thing about an underlying universal reality, similarly distorts what careful engagement with the traditions establishes. The traditions differ substantially in their specific theological commitments. The Christian framework of the Trinity and the incarnation of Christ is not the same as the Hindu framework of Brahman and the multiple expressions of divine reality through specific deities. The Buddhist framework of the absence of a permanent self is not the same as the Hindu framework of the eternal Atman. The Taoist framework of Tao is not the same as the Christian framework of the personal God. The traditions arrive at frameworks that bear striking structural resemblance to each other on specific questions, but they remain genuinely distinct traditions with substantively different theological commitments. The careful engagement with these traditions requires recognizing both their structural convergences and their substantive differences. The popular framework of perennialism, which dissolves the differences into an underlying common essence, does not survive careful engagement with what the traditions themselves articulate. The careful position, which the documentary maintains, is that the convergences are real and worth examination, while the differences are real and deserve to be respected. The popular framework of the simulation hypothesis, the position that we are living in a computer simulation created by some external intelligence, has been articulated by various contemporary thinkers, including the Swedish philosopher Nick Bostrom in his 2003 paper, Are You Living in a Computer Simulation?, and has been popularized through various subsequent works. The framework draws on the recognition that contemporary physics has revealed structural features of reality that are similar in some respects to the structures of information processing, and proposes that the underlying reality might therefore be informational rather than material in the way classical physics had assumed. The framework is not a contemporary scientific theory in the same way that quantum mechanics is a scientific theory. The framework is a philosophical speculation about the nature of reality that draws on specific features of contemporary physics without being established by the physics. The framework has parallels with various traditional frameworks, including the Hindu doctrine of Maya and the Buddhist Yogacara doctrine of mind only, but it differs from these traditional frameworks in important respects. The traditional frameworks treat the appearance of the material world as the surface manifestation of a deeper consciousness that pervades the cosmos. The simulation hypothesis treats the appearance of the material world as the product of computational processes operated by external intelligences. The frameworks are not equivalent. The simulation hypothesis, in its specific contemporary articulations, draws on cultural assumptions about computational processes that the traditional frameworks did not share. The framework deserves serious philosophical engagement, but it should not be conflated with the careful convergences between contemporary physics and the great traditions that we have been examining. What the careful convergences establish, when properly understood, is something more modest and more philosophically interesting than the popular extensions suggest. The convergences establish that the questions about consciousness, observation, time, connection, death, and the broader structure of reality are not questions that contemporary science has settled in favor of the materialist framework. The convergences establish that the great traditions of the world have addressed these questions across millennia with serious philosophical and contemplative resources, and that contemporary physics has revealed structural features of reality that are at minimum compatible with what these traditions have articulated. The convergences do not establish any specific traditional framework as scientifically validated. The convergences do not establish that the popular extensions of the traditional frameworks are correct. The convergences establish that the question of how to understand the situation in which we find ourselves remains genuinely open, and that careful engagement with multiple resources beyond contemporary materialism is a legitimate intellectual enterprise rather than a retreat from the implications of contemporary science. What does this mean for you, the person who has followed this documentary through to its conclusion? What does it mean for the question of how to understand your own situation as a conscious being embedded in the broader structure of physical reality? The documentary cannot answer this question for you. The documentary can offer resources for the answer. The resources include the recognition that the materialist framework that the previous century had treated as definitively established is not adequate to what contemporary physics has revealed. The resources include the recognition that the great traditions of the world have articulated frameworks that contemporary physics has not refuted and that may bear on the deeper question of what your situation is. The resources include the recognition that the questions about consciousness, meaning, and what happens at death are questions that careful philosophical and contemplative engagement can address, even when the available resources fall short of definitive answers. What you make of these resources is yours alone to develop. The documentary has offered them. The development is yours. There is one further consideration that bears mentioning before this final stage closes. The traditional frameworks were developed not merely as intellectual systems for explaining the structure of reality. The traditional frameworks were developed as practical resources for living a life that is appropriate to the deeper reality that the frameworks articulate. The Christian framework was developed not merely as theology, but as a way of life involving specific practices, including prayer, sacramental participation, ethical commitments, and the cultivation of specific virtues. The Hindu and Buddhist frameworks were developed not merely as philosophy but as paths of practice, including meditation, ethical conduct, and the cultivation of specific states of consciousness that the frameworks treat as accessible through sustained practice. The Taoist framework was developed not merely as cosmology, but as a way of living in accord with the broader patterns of Tao. The traditions treated the deeper reality that they articulated as something that could be engaged through specific practices, rather than merely understood through specific frameworks. What the convergences between contemporary physics and the traditions suggest is that the deeper reality that the traditions were articulating may be genuinely there in ways that the materialist framework could not accommodate. If the deeper reality is genuinely there, then the practices that the traditions developed for engaging it may bear on more than merely the specific frameworks within which they were articulated. The practices may bear on the broader question of how to live a life that is appropriate to what we actually are at our deepest level. Whether this implication should be taken seriously, or whether it should be regarded as overreaching what the physics actually establishes, is a question that the documentary cannot settle. The question is one that careful philosophical and contemplative engagement may help to address, even when contemporary physics cannot by itself provide the answer. The convergence between contemporary physics and the great traditions is, as we have observed across the previous stages, striking. It is not proof. The convergence has been articulated by physicists who arrived at it through their engagement with the implications of their own rigorous scientific work, not through prior commitment to any specific religious tradition. The convergence has been articulated by careful philosophers and theologians who arrived at it through their engagement with the implications of the traditional frameworks for contemporary thought, not through prior commitment to any specific scientific position. The convergence has emerged independently from multiple directions, and it has emerged in ways that the participants themselves often found surprising rather than expected. Schrödinger did not begin his work expecting to be led to Vedanta. Wheeler did not begin his work expecting to be led to a participatory universe framework with structural parallels to the Upanishads. Bohm did not begin his work expecting to be led to a framework with structural parallels to the Buddhist Avatamsaka tradition. The convergence emerged as the implications of the physics worked themselves out across the decades of the 20th and early 21st century. The emergence has been surprising. The emergence has been resisted by many serious thinkers. The emergence has been embraced by others. What the emergence means for the broader question of how to understand the situation in which we find ourselves remains, as we have observed, an open question. The documentary closes with a final reflection on what the entire investigation has and has not established. What has been established is that contemporary physics has reopened questions that the materialist framework of the previous century had treated as closed. The reopening is genuine. What has been established is that the great traditions of the world have articulated frameworks across millennia that bear striking structural resemblance to what contemporary physics has been suggesting in its various interpretations. The resemblance is striking. What has not been established is that any specific traditional framework has been scientifically validated. What has not been established is that the popular extensions of the convergences are correct. What has not been established is that the question of how to understand the deeper structure of reality has been settled in any direction. The investigation has revealed that the question is more open than the materialist framework had assumed, that careful engagement with multiple resources is a legitimate enterprise, and that the answer to the broader question of how to understand the situation in which we find ourselves remains genuinely open to whatever you bring to its development. The investigation has been an offering rather than a conclusion. What you make of the offering is yours alone to develop. The documentary closes with that recognition, with the hope that the resources it has offered may bear on the broader question of how to understand the situation in which you find yourself, and with the acknowledgement that the deeper engagement with that question is something that no documentary can complete for you. The completion lies in your own continued engagement with what the documentary has offered, and with whatever other resources you bring to the broader question. The thesis with which this documentary began can now be stated in its complete form. Quantum mechanics sits at the edge where science begins to raise questions once reserved for philosophy, theology, and spirituality. As science advanced, the influence of traditional religion weakened in many areas, yet modern quantum theories unexpectedly opened new ways for people to interpret consciousness, reality, and existence itself. Most of the topics that this documentary has discussed are theoretical, and the documentary has left the interpretation entirely to the viewer. What the documentary has shown is that the topics are real, that they have been addressed seriously by contemporary physicists and by the great traditions of the world, and that the convergences between contemporary physics and the great traditions are genuine even when they fall short of proof. The documentary has shown that the questions that earlier centuries had addressed through philosophical and theological frameworks are questions that contemporary thought has had to engage seriously rather than dismiss. The documentary has shown that the materialist framework of the previous century is not adequate to what contemporary physics has revealed, and that careful engagement with multiple resources beyond contemporary materialism is a legitimate intellectual enterprise. What the documentary has not shown is that any specific religious or philosophical framework is correct. What the documentary has not shown is that the popular extensions of the convergences are valid. What the documentary has not shown is that the deeper questions of consciousness, meaning, and what happens at death have been settled in any specific direction. The documentary has been an inquiry rather than a conclusion, and the conclusion lies in your own continued engagement with what the inquiry has revealed. We close then with what we have. We have a contemporary physics that has revealed structural features of reality that the merely materialist framework cannot adequately accommodate. We have a body of traditional wisdom developed across thousands of years that articulates frameworks bearing striking structural resemblance to what contemporary physics has been suggesting. We have a convergence between these two inquiries that is genuine, that is striking, and that falls short of proof. We have the recognition that the convergence permits multiple interpretations, that the choice between these interpretations depends on broader philosophical and theological commitments, and that the choice is one that careful engagement may help to address, even when no single answer can be definitively established. We have, finally, the recognition that the question of how to understand the situation in which we find ourselves remains genuinely open. The materialist framework that the previous century had treated as definitively established is not adequate to what contemporary investigation has revealed. The traditional frameworks that the previous century had treated as superseded have turned out to address questions that contemporary investigation has had to take seriously. The path forward is not a return to traditional religion in any naive sense. The path forward is also not a continuation of materialism in any complacent sense. The path forward is the careful engagement with whatever resources may bear on the broader question, with the recognition that the resources include both contemporary physics and the wisdom of the great traditions, and with the acknowledgement that the deeper engagement requires more than any single resource can provide. This is where we end. This is where the documentary turns back to you. The convergences are striking. The convergences are not proof. What follows from the convergences depends on what you bring to their interpretation. What the documentary has offered is the recognition that the convergences are real, that they bear on questions of substantial importance, and that careful engagement with them is a legitimate enterprise. What you make of the offering is yours alone to develop. The development is the broader engagement with the question of how to understand the situation in which you find yourself. With whatever resources you bring to that engagement, and with whatever conclusions you eventually arrive at, the documentary has been an offering. The development is yours. The deeper question is yours. The answer, whatever you eventually develop it to be, is yours alone to develop and to live by. We close with that recognition, with gratitude for your having followed the investigation through to its conclusion, and with the hope that the resources the documentary has offered may bear on whatever you make of the broader situation in which we all find ourselves. Whatever you make of it, the making is yours. The making is what the inquiry has been pointing toward all along. The questions are yours. The resources have been offered. The continued engagement with the questions is what remains, and what remains is what matters most.